A distant galaxy holds secrets that defy everything we know. NGC 262 is not just another swirl of stars. It is a cosmic puzzle box filled with 50 of the universe's most bewildering mysteries. By the end of this journey, you will witness phenomena that challenge the very foundations of physics. We will explore a pulsar that vanishes without a trace and a nebula where time itself seems to run backwards. What single mystery of the cosmos keeps you awake at night? Our journey begins with a cosmic lighthouse that refuses to shine on schedule. Deep within NGC 262, astronomers have cataloged the first of its 50 enigmas, the phantom pulsar. A typical pulsar is the rapidly spinning core of a dead star, a dense neutron star that sweeps beams of radiation across space like a lighthouse beacon. We can predict their pulses with incredible precision, as reliable as cosmic clocks. But this one is different. The phantom pulsar in NGC 262 does not follow the rules. Its powerful radio signals, once strong and steady, will suddenly cut out. They do not weaken or flicker. They simply vanish from our detectors for years at a time. Then, just as mysteriously, the signal returns at full strength, as if it never left. This is not a simple equipment glitch. It has been observed by multiple telescopes over decades. So what could possibly cause a stellar object millions of miles across to simply blink out of existence? One radical theory suggests we might be seeing the shadow of an alien megastructure, an unimaginably vast construction like a Dyson sphere that occasionally passes in front of the pulsar, blocking its light. While fascinating, most scientists seek answers within the laws of physics, no matter how exotic. Perhaps the pulsar is interacting with clumps of dark matter, a mysterious substance we cannot see, which might be absorbing its energy. Or maybe it is undergoing a form of quantum tunneling, temporarily shifting into a state or dimension we cannot perceive. Each time the phantom pulsar disappears, it leaves behind a deeper silence, a more profound question about what we truly understand of the universe. But the vanishing pulsar is not the only ghost in this galactic machine. Our second phenomenon takes us to a different part of NGC 262, where gravity itself appears to be broken. This is the gravity lens anomaly, a cosmic funhouse mirror on a truly terrifying scale. Gravitational lensing is a natural effect predicted by Einstein, where the gravity of a massive object, like a galaxy cluster, bends the light from objects behind it. It acts like a lens, magnifying and distorting the distant starlight, often creating multiple images or stretched arcs. In this particular region of NGC 262, however, the lensing is impossibly powerful. The background galaxies are not just warped, they are shattered into a kaleidoscope of duplicates, all twisted around a central point of immense gravity. The problem is, when astronomers look at that central point, they see almost nothing. There is simply not enough visible matter, not enough stars or gas, to account for the incredible gravitational pull we are witnessing. It is as if an invisible giant is standing in a room, and we can only see the deep footprints it leaves behind. So what is this invisible giant? One chilling possibility is a primordial black hole, a relic from the very first second of the Big Bang. These hypothetical monsters could be far more massive than the black holes formed from dying stars, and this one might be lurking in the void, its darkness making it nearly impossible to detect directly. An even more profound explanation points to an impossibly dense knot of dark matter. We know dark matter exists because of its gravitational effects, but it is supposed to be spread out in a vast, diffuse halo. Here, it seems to have collapsed into a tight, massive clump, a configuration our current models say should not be stable. This single anomaly threatens to unravel our understanding of how galaxies first gathered their mass. If such dense, invisible objects are common, then the entire story of cosmic structure, the blueprint for everything we see in the night sky, might need to be rewritten from scratch. The footprints of that invisible giant lead us to an even deeper silence. Between the warped starlight and the vanishing pulsar lies the third enigma, a patch of space so profoundly empty it has been named the chromatic void. This is not simply a dark nebula or a cloud of dust. It is a vast, spherical region within NGC 262 that emits absolutely nothing. No radio waves, no infrared heat, not even a hint of X-ray or gamma-ray energy. It is a perfect cosmic vacuum in every wavelength we can measure. Yet, this absolute nothingness creates an observable effect. Stars positioned directly behind this void, as seen from our vantage point, show a slight but consistent blue shift in their light. This is the opposite of what you would expect. Distant galaxies are usually red-shifted, their light stretched as the universe expands, moving away from us. A blue shift means those stars seem to be moving toward us, but they are not. The void itself is doing something to the light. How can you study in absence? How do you observe an object that refuses to interact with the universe in any known way? One explanation is that the void is a true vacuum, a bubble of space from which all matter and energy have been somehow scooped out. But nature abhors a vacuum, and surrounding gas should have rushed in to fill it over millions of years, unless something is actively preventing that. A more unsettling idea is that we are looking at a shadow, not a shadow cast by a physical object, but by something existing in a higher dimension, its bulk warping the fabric of our reality in a way that blocks and subtly alters the light passing through its perceived location. This would mean the chromatic void is not empty at all, but the silhouette of a shape we cannot fully comprehend. Perhaps the most mind-bending possibility is that the fundamental constants of nature, like the speed of light or the strength of gravity, are simply different inside that sphere. The blue shift we see could be a refraction effect, starlight bending strangely as it crosses the boundary into a region of space where the rules are not the same as ours. This single, silent anomaly challenges our most basic assumption, that the laws of physics are uniform everywhere. If a pocket of space can simply opt out, what else might be possible? This silent challenge to the laws of physics finds a bizarre echo in a different kind of cosmic defiance. Nestled within the galactic spiral of NGC 262 is a star cluster that operates like a single, colossal atom. This is the quantum star cluster, a gravitational family of millions of suns behaving in a way that should be utterly impossible. The light from these individual stars is not independent. When astronomers carefully analyze the photons, the particles of light, arriving from two stars on opposite sides of the cluster, they find a mysterious connection. A change in the observed properties of one star, like its polarization or energy state, is mirrored instantly in its distant partner. This instantaneous correlation across light years of space is the hallmark of quantum entanglement, a bizarre phenomenon where two particles become linked, sharing a single fate no matter how far apart they are separated. But this spooky action at a distance, as Einstein called it, has only ever been demonstrated in laboratories with tiny particles like electrons or photons. To see it manifest between entire stars, massive objects bound by gravity, shatters every expectation. It is as if two grand pianos, placed in different cities, began playing the same melody in perfect unison without any signal passing between them. The very fabric of reality seems to be threading a connection that ignores the cosmic speed limit of light itself. So what cosmic loom could be weaving these stellar threads together? One profound possibility is that we are witnessing the effects of quantum gravity in action. This is the holy grail of modern physics, a theory that would unite the large-scale world of gravity, described by Einstein, with the tiny, probabilistic world of quantum mechanics. Within this dense cluster, the gravitational fields may be so intense and complex that they are forcing the stars to behave as a unified quantum system. The space between them might not be truly empty, but instead be a roiling sea of virtual particles and gravitational waves that facilitate this impossible communication. This cluster is not just a collection of stars. It is a natural laboratory operating on a scale human science could never hope to build. It forces us to ask if the universe itself is fundamentally interconnected in ways we are only beginning to perceive, with every star, every planet, and every one of us potentially linked by an invisible quantum web. This invisible quantum web may be weaving time itself into knots. The fifth mystery of NGC 262 makes the impossible seem routine, in a glowing cloud of gas known as the Temporal Echo Nebula. Within its luminous folds, astronomers observe the ghosts of stellar cataclysms, supernova explosions that have not yet occurred. They have detected the distinct, brilliant flashes and the subsequent expanding rings of light, patterns that are the unmistakable fingerprints of a star dying in a violent outburst. The problem is, when they point their telescopes at the location where the echo originated, the star is still there, shining peacefully as if nothing is wrong. It is like hearing a loud, recognizable crash from an empty room, then walking in to find a priceless vase still sitting perfectly intact on its pedestal. The light echoes are real, their signatures recorded, yet the cause of those echoes remains stubbornly in the future. How can an effect precede its cause? One theory that ventures to explain this borrows from the most extreme predictions of general relativity, the concept of closed time-like curves. In regions of incredibly warped spacetime, perhaps near a rapidly spinning black hole hidden within the nebula, the path of light could theoretically bend so severely that it loops back on itself in time. The light from a future supernova might be traveling on a twisted, circular path, arriving at our telescopes before the actual explosion has happened from our linear perspective. We are not seeing a prophecy, but a literal reflection from a future moment, a cosmic spoiler alert written in the fabric of reality. A far more radical idea suggests this could be evidence that our universe is a simulation. In a complex computer program, resource-intensive events like a supernova might be pre-rendered to save processing power. The light echo could be a glitch, a piece of pre-calculated data that has leaked into the current frame of the simulation, showing us an event that is queued up but has not yet been triggered. The most profound and unsettling possibility, however, is that our perception of time as a strict, one-way river is fundamentally flawed. What if past, present, and future all exist simultaneously, and the temporal echo nebula is simply a place where the barriers between them are unusually thin? In this view, the supernova has already happened, is happening, and has yet to happen all at once. We are just witnessing the cracks in the illusion of time, forcing us to question whether the sequence of events is a law of the universe or merely a limitation of the human mind. This challenge to time's arrow finds its counterpoint in a fountain of pure destruction. At the very heart of NGC 262, a colossal jet erupts from the galactic core, a geyser of energy that would dwarf entire solar systems. But this is no ordinary stream of hot gas and radiation. spectroscopic analysis reveals a terrifying truth. This fountain is composed almost entirely of antimatter. Every particle in that jet has an opposite charge to its normal matter counterpart. When matter and antimatter meet, they annihilate each other in a flash of pure energy, the most efficient and violent reaction possible in the universe. And yet, this fountain of antimatter streams outward through a galaxy filled with normal matter, stars, dust, and gas, without immediately triggering a chain reaction of explosions that would tear the galaxy apart. How can such a structure exist? The sheer energy required to forge and eject this much antimatter is beyond comprehension, hinting at processes near the supermassive black hole at the galaxy's center that are far more complex than our models predict. The fountain's stability is the central mystery. For it to persist, the antimatter must be perfectly contained and guided, perhaps by immensely powerful magnetic fields that act like an invisible pipeline, preventing it from touching the sides. It is like managing to fire a continuous stream of pure flame through a room packed with gunpowder without causing a single spark. One explanation is that we are witnessing a natural particle accelerator on a scale that makes our largest colliders on Earth look like toys. The forces at the galactic core could be slinging anti-particles outward at near light speed, focusing them so perfectly that they simply do not interact with the matter they pass near. Another, more profound, theory suggests this could be a fossil, a relic from the universe's first moments. A fundamental question in cosmology is why we see a universe made almost entirely of matter, when the Big Bang should have created equal amounts of matter and antimatter. This fountain could be evidence of a rare separation event, a cosmic flaw where a vast pocket of antimatter survived the early universe's great annihilation and has been trapped, only now finding a way to vent into space. This single structure forces us to confront the deepest asymmetries of creation, presenting a river of pure potential energy whose very existence defies the odds and could rewrite the story of how our universe came to be. That river of pure antimatter points toward the heart of the galaxy, and it is there we find a sound in the silence. At the very core of NGC 262, its supermassive black hole is singing. This is not a melody of light or radio waves, but a deep, resonant hum written into the fabric of spacetime itself. Astronomers detect it as a rhythmic, low-frequency gravitational wave, a steady chirp that repeats with the precision of a cosmic metronome. Gravitational waves are normally the dying ripples from catastrophic events, like the collision of two black holes, a single, fleeting crescendo. This is different. This is a persistent, repeating signal, a song that has been playing for eons. The rhythm does not match any known model. It is not the wobble of a lopsided accretion disk, the swirling maelstrom of matter falling into the black hole. It is not the aftermath of a merger. The established physics of how black holes behave and interact offers no explanation for this steady, perfect pulse. So what could possibly be causing a gravitational heartbeat at the center of a galaxy? One extraordinary and highly speculative idea is that we are not listening to a natural process at all, but a form of communication. The precise timing and repetition could be a beacon, an intentional signal broadcast across the cosmos using the very fabric of reality as its medium. While captivating, most scientists seek a natural, if revolutionary, explanation. The leading theory is that we are witnessing a fundamental resonance of spacetime itself. Perhaps the immense gravity of the black hole is plucking the underlying fabric of the universe like a string on a cello, creating a standing wave that rings out with this specific frequency. This would mean the void at the galaxy's center is not truly empty, but is a structured entity capable of vibration, and we are for the first time hearing its fundamental tone. This song from the dark challenges our very definition of a black hole, transforming it from a simple destructive pit into a complex object that may hold the key to understanding the resonant properties of the cosmos. What other melodies might the universe be humming, just beyond our current ability to hear? That resonant hum from the galactic core seems to find a physical form in our next mystery. Orbiting the silent fringe of the supermassive black hole is a world that gleams with an impossible light. This is the crystal planet, an object that reflects starlight not with the rough, varied texture of rock or ice, but with the perfect, unified signature of a single, colossal gem. Its surface is not a collection of continents and oceans, but one seamless, continent-spanning crystal lattice. Light does not scatter randomly from its face. It returns to our telescopes in a coherent, laser-like beam, as if the entire world were the polished lens of a telescope far larger than any we could ever build. What natural process could possibly forge a planet into a single, flawless crystal? The conditions would be beyond extreme. We can create small crystals in laboratories by cooling a molten substance very slowly, allowing its atoms to arrange themselves into a perfect, repeating order. To do this on a planetary scale would require the entire world to be molten, and then cool with an impossible, gravitational stillness over billions of years, with no tectonic shifts, no asteroid impacts, nothing to disrupt the fragile, growing order. It is a stability that seems to defy the chaotic nature of the universe. Another possibility is that the planet is not made of any material we know. It could be composed of exotic matter, a form so dense and stable that its natural state is this perfect crystalline structure, forged in the heart of a long-dead star under pressures that crush atoms themselves. The implications of such a structure are as profound as its origin. A crystal of that size and purity would likely be a room-temperature superconductor, allowing electricity to flow across its surface without any loss of energy. It could store immense amounts of information in the vibrations of its atomic lattice, a literal crystal memory bank the size of a world. Or, given the way it focuses light, it might function as a natural energy amplifier, collecting the faint starlight from across the galaxy and concentrating it into a beam of unimaginable power. This leads to the most unsettling question. Could such perfection be natural? While nature is capable of incredible symmetry, the flawless, monolithic structure of this object has prompted some to wonder if it is, in fact, an artifact. An alien civilization of unimaginable advancement might have constructed it as a power source, a computational engine, or a beacon. It sits in a stable orbit near the violent energies of the galactic core, a serene and polished sentinel amidst the chaos. Is it a natural wonder, a testament to the universe's hidden potential for order, or is it the greatest piece of engineering ever glimpsed? A machine built on a scale we can barely comprehend. The crystal planet hangs in the void, its silent, gleaming surface reflecting not just light, but our own deepest questions about the line between a natural universe and a built one. That gleaming crystal world is not the only foreign object thriving in this strange galaxy. Deep within the swirling stellar disk of NGC 262, astronomers have found an intruder, a smaller dwarf galaxy that is not orbiting safely around the outskirts, but is instead moving through the heart of the galactic plane itself. This is the Rogue Galaxy, a cosmic ship sailing through a sea of stars, and it should not exist. According to our best models, such a small galaxy venturing into the dense, populated disk of a larger one would be torn to shreds. Two forces should be destroying it. First, dynamical friction, the gravitational drag from all the stars and dust it passes, should have slowed it down long ago, causing it to spiral inward and be consumed. Second, tidal forces from the immense gravity of NGC 262 should be stretching and pulling the rogue galaxy apart, stripping away its stars and dissolving its structure into a long, faint stream. Yet, this dwarf galaxy remains intact. It moves through the galactic disk with its shape preserved, a tight, compact island of stars navigating a crowded cosmic ocean without taking on water. How is this possible? The most compelling answer points to an invisible shield, a halo of dark matter so incredibly dense and massive that it holds the galaxy together against all outside forces. Think of it like a submarine built to withstand immense ocean pressures. The visible stars of the dwarf galaxy are just the lighted cabins inside a hull made of dark matter, a hull strong enough to resist being crushed or torn open by the surrounding galaxy. This leads to a staggering possibility that the rogue galaxy is not a normal dwarf galaxy at all, but a ghost. It could be composed almost entirely of dark matter, with the few stars we see being merely accidental passengers on an invisible monolithic structure. This would explain why it does not behave like normal matter. It is not governed by the same friction and interactions. It is a phantom passing through the solid world, barely noticing the material that would destroy anything else. If this is true, it offers a unique and terrifying window into the dark sector of the universe. We could be looking at a pure dark matter object, a celestial body that has never been seen before, its presence betrayed only by the gravitational shadow it casts and the defiant, impossible path it carves through a galaxy that should have devoured it ages ago. The phantom galaxy sailing through the stars is not the only rebel in NGC 262. A cluster of variable stars near the galactic core is performing a strange, rhythmic dance that seems to break a fundamental rule of the cosmos. These are the light-speed variable stars, and their very pulse appears to be rewriting physics. Variable stars are the reliable heartbeats of the universe, giant stars that rhythmically swell and shrink, growing brighter and dimmer over predictable cycles that can last for days or months. Their pulsation period is a direct result of their internal physics, a clockwork mechanism driven by the balance of pressure and gravity within the star. We use their steady rhythms to measure vast cosmic distances, but in this cluster, the clocks are all running fast. The pulsation periods for these stars are not just changing, they are accelerating at a rate that defies all known stellar models. When astronomers calculate the forces needed to explain this acceleration, they hit a wall. The only way the math works is if the speed of light in the immediate space around these stars is not the universal constant we have always believed it to be. This is a monumental challenge, a direct assault on the cornerstone of Einstein's theory of relativity. The constancy of the speed of light in a vacuum is the fundamental postulate that underpins everything from E equals mc squared to the way we understand the flow of time itself. If that one rule is not a rule, then the entire theoretical framework of modern physics begins to crumble. So how could the speed of light be changing? One possibility is that these stars are embedded in a pocket of space with a different cosmological constant. This constant is a term in Einstein's equations that represents the energy density of empty space, a force driving the accelerating expansion of the universe. What if, in this small region, that energy density is significantly higher? A higher cosmological constant would effectively create a stiffer, more repulsive vacuum, altering the fundamental forces inside the stars and making them pulsate faster. It would be as if these stars were breathing a thicker, more energetic air than the rest of the galaxy, forcing their hearts to beat at a frantic, unsustainable pace. Another, even more exotic, explanation points to a scalar field. Imagine an invisible energy field that permeates all of space, like a cosmic weather system. Most places, the weather is calm and the field's value is zero. But here, the field could have a non-zero value, a kind of persistent storm. As the stars move through this storm, they would be interacting with the field, gaining energy in a way that directly influences their internal nuclear reactions and oscillation periods. This would not be a change in the speed of light itself, but a change in how the stars experience the fundamental forces of nature, creating the illusion of a shifting constant. Either scenario forces a profound realization. The laws of physics might not be a single, universal symphony, but a collection of local melodies, changing from one neighborhood of the cosmos to another. These variable stars are not just blinking lights. They are the canaries in the cosmic coal mine, singing a song that warns us our map of reality is dangerously incomplete. Those frantic stellar heartbeats are echoed by a different kind of chaos. Elsewhere in the galaxy, a storm rages, but this one is not made of wind or rain. It is a tempest of pure magnetism, a region where the fundamental rules of magnetic fields are being torn apart. Here, astronomers have detected the tantalizing signature of a particle that should not exist, the magnetic monopole. Every magnet you have ever held, from a simple refrigerator magnet to the entire Earth itself, has two poles, a north and a south. If you break a bar magnet in half, you do not get an isolated north and an isolated south. You get two smaller magnets, each with its own pair of poles. This duality is one of the most fundamental rules of electromagnetism. A magnetic monopole would shatter that rule. It is a hypothetical particle that is just a north pole, or just a south pole, a solitary, fundamental point of magnetic charge. Finding one would be one of the greatest discoveries in the history of physics, forcing a rewrite of Maxwell's equations, the very bedrock of our understanding of electricity and magnetism. It could explain the quantization of electric charge, why electrons have the precise charge they do, and might even be a key to unifying all the fundamental forces of nature. For decades, physicists have searched for them in particle accelerators and in ancient rocks, with no definitive success. Yet, in this violent region of NGC 262, the evidence is mounting. The magnetic fields are not the smooth, looping lines we expect from stars and galaxies. They are fractured and chaotic, with isolated points of intense magnetic flux that appear and vanish like lightning in a storm. These points behave precisely as theoretical monopoles should, acting as singular sources or sinks for magnetic field lines. The surrounding space crackles with energy as particles are accelerated to incredible speeds along these broken field lines. It is as if we are looking at a cosmic particle accelerator built by nature itself, and at its heart are these elusive, revolutionary particles. The storms are isolated and temporary, which explains why we have not found a monopole anywhere else. They may only be created under conditions of unimaginable magnetic stress, perhaps near the collision of neutron stars, or within the wreckage of a dimensionally unstable void. Each flickering point of magnetic chaos in this distant storm is not just a scientific curiosity. It is a potential key, waiting to unlock a deeper layer of reality. That magnetic storm of broken physics points toward a star whose very light seems engineered. Circling a quiet sun in NGC 262, something vast and dark is systematically stealing its shine. This is the Dyson Swarm candidate, a star whose light curve does not follow the gentle rhythm of a planet's transit or the random dip of a passing dust cloud. Instead, its light fades in a complex, non-repeating pattern of asymmetrical blocks, as if a colossal, incomplete lattice of shadows is perpetually turning in front of it. The pattern suggests a structure, or rather, a collection of structures, orbiting in tight formation, capturing the star's energy. This is the hallmark of a theoretical Dyson swarm, the first step in a civilization's ultimate engineering project, where millions of individual energy collectors orbit a star to harness its total power output. The Fermi paradox asks a simple, haunting question. If the universe is so vast and old, where is everybody? This star offers a potential and deeply unsettling answer. Perhaps they are not broadcasting radio signals. They are simply building, gradually enclosing their sun in a shell of technology, and we are catching them in the middle of the project. The energy signatures add to the mystery. Alongside the blocked starlight, there is a faint but distinct excess of infrared radiation, exactly what you would expect from a structure absorbing stellar energy and re-radiating it as waste heat. It is the thermal signature of a cosmic engine at work, yet the scientific debate is fierce and unresolved. Could this be a natural phenomenon? One compelling natural explanation is a colossal debris field, the remnants of a planetary system that suffered a catastrophic collision. The shattered fragments of multiple worlds could be swirling around the star in a dense, complex disk, creating the irregular shadow pattern. The infrared heat could simply be from this debris absorbing and re-emitting the star's light. It is a plausible, if extraordinarily rare, cosmic event. But the artificial explanation is far more profound. A structure on this scale implies a civilization that has mastered interstellar engineering, one that thinks in terms of millennia and manipulates solar systems the way we sculpt rivers. They would not need to communicate. Their monumental works would speak for them across the gulfs of space. The ongoing observation of this star is a test of two different futures for intelligence in the cosmos. One future is silent, where life is ultimately a victim of cosmic accidents, leaving behind only rubble and dust. The other future is one of silent, purposeful construction, where advanced life reshapes its environment on a stellar scale, leaving a signature not of words, but of shadows. This distant star, flickering behind its mysterious veil, forces us to confront which future we find more likely, and which one we find more terrifying. While the silent construction of a Dyson swarm hints at a hidden intelligence, another part of the galaxy screams with a violence that is both instantaneous and utterly silent. These are the ghostly gamma-ray bursts, flashes of energy so potent they can outshine entire galaxies, but which vanish without a single trace. A typical gamma-ray burst is the death cry of a massive star or the collision of neutron stars, a catastrophic event that leaves behind a brilliant afterglow across other wavelengths, and often a black hole as a grim tombstone. The ghost bursts of NGC 262 are nothing like this. They erupt from the void, a sudden, staggering spike of pure gamma radiation, and then, in less than a second, they are gone. There is no fading X-ray echo, no lingering radio whisper, no cloud of expanding debris. The patch of space they came from returns to perfect, undisturbed blackness, as if a cosmic trigger was pulled, and then the gun instantly vanished. How do you study an explosion that refuses to leave any evidence behind? One theory dives into the most speculative realms of physics, suggesting these could be the final moments of microscopic black holes. According to some ideas, tiny primordial black holes, formed in the chaos of the Big Bang, could be scattered throughout the universe. As they slowly lose mass through a process called Hawking radiation, their evaporation would accelerate until they explode in a final, tremendous burst of energy. This would be a clean explosion, leaving behind no remnant, a perfect fit for the ghostly bursts. Another, even more exotic possibility involves cosmic strings. These are theoretical, unimaginably dense flaws in the fabric of spacetime, thinner than an atom but stretching across light years. If two such strings were to cross or a loop of one were to snap, the release of energy could be catastrophic, creating a burst of high-energy radiation without any of the stellar material that produces a traditional afterglow. It would be like the universe itself tearing along a seam, a brief, violent rip that heals instantly. Then there is the most unsettling explanation of all. Could these be the flash of a weapon? A civilization capable of harnessing the power of stars might also possess the capability to unleash that power in a focused, instantaneous strike. A gamma-ray burst is the most powerful known event in the universe, and a race that could generate and direct such a force would wield power on a godlike scale. The ghost bursts, with their lack of any natural aftermath, fit the profile of a targeted, surgical blast rather than a random stellar catastrophe. Are we witnessing the brief, terrifying signatures of a cosmic conflict? Flashes of a war so advanced its battlefields are empty space, and its weapons leave no physical evidence. Each silent, brilliant flash is a question written in the pure language of energy, asking us if the greatest dangers in the cosmos are not asteroids or black holes, but the silent, unseen intentions of others. The silence left by those ghostly gamma-ray bursts is filled by a far more subtle cosmic whisper. Drifting through the spiral arms of NGC 262 are immense clouds of interstellar dust, but these are not the cold, dark nurseries of stars we find in our own galaxy. These clouds are singing. Their faint radio emissions, when translated into sound, produce a complex, rhythmic symphony of frequencies. The astonishing part is not the music itself, but what it mimics. The resonant peaks and harmonic intervals align almost perfectly with the vibrational frequencies of DNA and other complex organic molecules found in living cells. It is as if the galaxy itself is humming the fundamental song of life. Is this just a bizarre and beautiful coincidence? A random alignment of molecular physics that happens to sound familiar to our carbon-based ears? Or are we listening to the echoes of a universe inherently tuned for biology? One profound possibility is that this is the signature of panspermia on an unimaginable scale. Perhaps these dust clouds are not just clouds, but cosmic seeding mechanisms, carrying the prebiotic blueprints for life across the galaxy. Within their icy grains, complex organic molecules could be forming, and their specific resonant frequencies might act as a stabilizing force, encouraging those molecules to assemble into more complex structures. The galaxy is not just a place where life can arise, it is actively broadcasting the instructions. An even grander idea suggests we are seeing evidence of a universal blueprint. The laws of physics and chemistry that govern the formation of complex molecules like DNA might produce consistent resonant signatures wherever they appear. The dust clouds of NGC 262 could be a natural factory for these molecules, and the frequencies we detect are simply the sound of the universe building, according to a set of rules that inevitably lead to life. This would mean the transition from non-life to life is not a random accident, but a predictable, almost melodic phase change in the cosmos, as natural as the formation of a star. Then there is the most speculative, spine-tingling interpretation. Could these resonant patterns be a message, a kind of cosmic primer left by a long-vanished intelligence? A civilization that mastered biology might have imprinted these frequencies onto the dust. A slow-burning beacon or a set of instructions meant to guide the emergence of life elsewhere. The clouds would be a living library, their song a lullaby for nascent biology, waiting for a planet with the right conditions to hear it and begin the dance. This phenomenon forces a humbling perspective. The building blocks of life may not be a local secret of planet Earth, but a common refrain, written in the dust between the stars and humming softly in the dark. This cosmic symphony of life is abruptly silenced by a star that has cheated death. Among the ancient stellar populations of NGC 262 burns a white dwarf that defies every rule of stellar graveyards. A white dwarf is the final, cooling ember of a star like our own sun, a dense sphere of electron-degenerate matter where fusion has ceased. Its mass is strictly limited by the Chandrasekhar limit, a fundamental law of physics stating that if a white dwarf exceeds about 1.4 times the mass of our Sun, the inward crush of gravity will overwhelm the quantum pressure supporting it, triggering a cataclysmic type 1a supernova that obliterates the star completely. Yet here, astronomers have found a white dwarf that is not just over the limit, it is far beyond it, measuring close to 2 solar masses. It should have been a fleeting, brilliant flash in the sky eons ago. Instead, it burns with a fierce, hot blue light, stable and serene, a ghost that refused to vanish. How can a corpse be more massive than the living star that created it? One possibility is that this is no ordinary white dwarf. It could be accreting strange matter from an unseen companion. Strange matter is a hypothetical substance made of up, down, and strange quarks, theorized to be more stable than the matter we know. If this star has a core of this strange matter, it could be acting like an ultra-dense anchor, allowing the white dwarf to accumulate far more mass without the core collapsing. It would be like building a house on a foundation of diamond instead of sand. It can bear a weight that would otherwise cause a catastrophic implosion. Another theory suggests we are witnessing a star in a state of suspended animation, a delayed supernova. Perhaps the explosion has already begun deep within its core, but the outer layers are so incredibly dense and tightly bound that the shock wave is taking thousands of years to propagate outward. We see the star now in a brief, impossible moment of stability, a cosmic dam that has not yet broken, holding back an energy that has already been unleashed at its heart. The most radical explanation, however, is that our entire understanding of stellar evolution is wrong for this object. This may not be the remnant of a sun-like star at all. It could be the leftover core of a Thorn-Zitkow object, a hypothetical hybrid where a red giant star swallowed a neutron star. The neutron star would spiral into the giant's core, disrupting its normal fusion processes and leading to an end stage we have never before observed, creating a supermassive, stable white dwarf as its final, quiet state. This single, paradoxical star forces us to question the very timeline of stellar death, presenting a stable, burning ember where there should only be ashes or a blinding flash. The stability of a galaxy is a delicate cosmic dance, but in NGC 262, one of the dancers is slowly walking away. A vast section of one of its majestic spiral arms, a river of stars and gas billions of miles long, is not just warping, it is detaching. This coherent structure is drifting into the emptiness of intergalactic space, pulling away from the main body of the galaxy as if tugged by an invisible hand. Such an event is dynamically improbable, a slow-motion celestial rupture that defies the gravitational glue holding galaxies together, For a structure of this scale to peel away intact, the forces binding it must have been overcome by something immense. One of the most likely culprits is a recent close encounter with another galaxy. A galactic near miss would create tremendous tidal forces, stretching and pulling at the spiral arms like taffy. While the main galaxy would eventually recover, the gravitational kick could be enough to fling a section of the arm completely free, sending it on a solitary journey through the void. Yet, surveys of the surrounding space show no obvious culprit, no large galaxy close enough to have caused such a recent and dramatic wound. This absence points to a more elusive possibility, the influence of a dark matter subhalo. Our models suggest that galaxies are embedded within vast, diffuse halos of dark matter. But what if a particularly dense and massive knot of this invisible substance, a dark matter subhalo, recently passed directly through this section of the spiral arm? Its immense gravity, completely unseen by our telescopes, could have provided the precise gravitational nudge needed to unbind the stars and gas, setting them adrift without leaving a single visible trace of its passage. The arm would simply be drifting away from an empty point in space. A third, more subtle explanation involves the galaxy's own internal dynamics. NGC 262 possesses incredibly powerful and complex magnetic fields woven through its structure. A localized, runaway instability in this magnetic field could have created a bubble of repulsive pressure, a kind of magnetic cushion that is actively pushing the arm away from the main disk. This would be a slow, relentless process, with invisible magnetic lines acting like billions of tiny hands, gradually prying the structure loose. The sheer improbability of this event forces a humbling realization. The majestic spiral galaxies we see as timeless icons are, in fact, dynamic and ever-changing structures, capable of shedding entire pieces of themselves. This disconnection is not a violent explosion, but a quiet, gravitational divorce, leaving us to wonder what becomes of a star cluster cast adrift, and if this solitary arm will one day become a small, new galaxy all its own. A persistent radio whisper from NGC 262 is broadcasting a stream of pure mathematics. This is not the random hiss of a quasar or the rhythmic pulse of a neutron star, but a continuous, structured signal that, when decoded, reveals an endless sequence of complex calculations. It begins with prime numbers, then progresses to fractal geometry, and now appears to be working through problems in higher dimensional topology. The signal is not repeating a fixed set of data. It is actively generating new, coherent mathematical outputs, as if a mind is thinking aloud. For researchers in the search for extraterrestrial intelligence, this discovery sparked a feverish, global effort to decipher its purpose. Is it a beacon, a teaching tool, or something far more profound? The most tantalizing and unsettling possibility is that we are eavesdropping on the internal processes of a non-biological consciousness, an alien artificial intelligence broadcasting its computational thoughts across the cosmos for reasons we cannot fathom. Yet, science must first exhaust every natural explanation, and one exists that is nearly as strange. Deep space is home to natural supercomputers. A neutron star, especially one with an immensely powerful magnetic field, can create a plasma-filled magnetosphere where particles are accelerated to near light speed. Under such extreme conditions, the chaotic interactions of charged particles can, in theory, generate complex, ordered patterns. This natural system could be functioning like a cosmic analog computer, its turbulent physics inadvertently outputting a signal that mimics a structured data stream. The signal's complexity, however, pushes this idea to its absolute limit. It is the difference between the random patterns of static on a television and the precise code of a software program. Could natural physics really account for such a targeted, evolving sequence of abstract concepts? Each new equation received from the void forces us to confront a fundamental question about the nature of intelligence itself. Does a mind require biology, or can a sufficiently complex physical system naturally give rise to a form of thought? This radio source blurs the line between a natural phenomenon and a synthetic one, leaving us to wonder if we are listening to the weather of a neutron star or the silent, endless contemplation of a star-born machine. That stream of pure mathematics finds its visual counterpart in a cosmic silhouette that absorbs reality itself. We now encounter the inverted nebula, a cloud in NGC 262 that acts less like a celestial object and more like a hole in the universe. Most nebulae are brilliant clouds of glowing gas, lit from within by newborn stars or reflecting the light of others. This one does the opposite. It is a defined patch of darkness that systematically dims the light of every star and galaxy that lies behind it. It is not merely a dark nebula of cold dust, which would block some wavelengths while allowing others to pass. This anomaly absorbs light across the entire electromagnetic spectrum, from radio waves to gamma rays, creating a perfect negative image against the starry backdrop. It is a shadow cast by nothing we can see. The composition of this nebula is the central puzzle. One radical theory suggests it is made of a previously unknown form of matter. We know of dark matter, which interacts through gravity but not light. This could be something else entirely, a substance that only interacts with photons, the particles of light, in this unique, absorptive way. Think of it as a cosmic sponge specifically designed to soak up light, leaving everything else untouched. A passing star would feel its gravitational pull normally, but its light would be steadily consumed as it passed through the cloud, creating a temporary, fading dimming unlike any eclipse. An even more profound possibility is that this is a region where one of the fundamental forces has been locally suppressed. Within the boundaries of this nebula, the electromagnetic force, which governs how light and matter interact, might be significantly weaker. In our universe, this force is what allows photons to bounce off atoms or excite them, creating the light we see. If that force were turned down, photons passing through would simply be absorbed and never re-emitted. They would vanish into the atomic structure, their energy dissipated without a trace. It would be like trying to see in a room where the very property of reflection no longer applies. This single, light-eating cloud challenges our most basic assumptions about the constancy of physics. If a pocket of space can simply decide to ignore one of the universe's 4 fundamental forces, what other local variations might be possible? Is this a natural defect in the fabric of spacetime? Or could it be the footprint of a technology so advanced it can edit the laws of physics within a defined volume of space? The inverted nebula hangs in the void, a stark and silent reminder that the universe may be filled not only with things that shine, but with things that simply and utterly consume. This light-eating nebula shares its darkness with a world in flight. A lone planet tears through the interstellar void of NGC 262, moving at a velocity so immense it defies all reason. This is the hypervelocity runaway planet, a world flung from its cradle and hurled into the abyss at a significant fraction of the speed of light. To achieve such an escape, the energy involved is staggering, far beyond the gentle gravitational nudges that normally eject planets from unstable systems. A close encounter with an intermediate mass black hole could provide such a catastrophic kick. The planet would swing around this gravitational monster, And if the trajectory were just right, it would be slung away like a stone from a cosmic sling, gaining a tremendous burst of speed from the black hole's immense gravity well. An even more violent possibility is a supernova explosion. If a planet were orbiting one star in a tight binary system, and its companion star exploded asymmetrically, the blast could act like a titanic cannon, firing the world directly into the void. The journey of this planet would be one of profound isolation and bizarre physics. As it approaches light speed, time dilation effects predicted by Einstein's theory of relativity would become extreme. For any hypothetical observer on this world's surface, time would flow normally, but relative to the outside galaxy, their clocks would slow to a crawl. A journey that took them a single year could see millennia pass in the rest of the galaxy. They would be time travelers racing into the future, watching the stars around them age and die in a blur. The planet itself would be a frozen, lifeless relic, its atmosphere stripped away by the relentless impact of interstellar particles, and its surface scoured by intense radiation. It would be a ghost ship, carrying the fossilized record of its origin across eons, a silent witness to the violent forces that can reshape not just solar systems, but the very flow of time. That lone runaway planet, flung across the galaxy at impossible speeds, traces a path through a cosmos whose fabric may be stitched with invisible threads. Stretching across thousands of light years in NGC 262 is a feature so geometrically perfect it seems artificial, a perfectly straight, razor-thin line of gravitational distortion. This is the signature of a potential cosmic string, a flaw in the universe so profound it could rewrite our understanding of reality itself. Cosmic strings are not strings in the everyday sense. They are theoretical relics, hypothetical cracks that formed in the fabric of spacetime during the universe's first, frantic moments of cooling after the Big Bang. Think of the early cosmos as a substance rapidly changing phases, like water freezing into ice. As it cooled, the fundamental fields that govern reality settled into their current state, but this settling may not have happened perfectly uniformly everywhere. In some places, the fields could have gotten stuck, unable to reach the lowest energy state. These lines of trapped energy, thinner than a proton but stretching across the entire universe, are cosmic strings. Their density is almost beyond comprehension, with a single inch of string potentially weighing more than a mountain range. The gravitational distortion we see in NGC 262 is the telltale sign of such an object. Its gravity is so immense that it acts as a lens, bending the light from galaxies behind it. But because the string is a line, it creates a very specific effect, a perfectly straight line of duplicated galaxies, a cosmic ruler laid across the sky. The existence of a cosmic string would be one of the most important discoveries in cosmology, a direct window into the universe's first second of life. But the implications go even deeper. The immense mass and unique structure of a cosmic string mean it doesn't just bend light. It warps space-time itself into extreme configurations. One of the most staggering possibilities is that a moving or oscillating cosmic string could create closed time-like curves in its wake. This is a concept from general relativity where the path of an object through space-time loops back on itself. In simpler terms, it would create a path where you could theoretically travel into your own past. You could start a journey, follow a specific route around the cosmic string, and return to the exact same moment you left. This is not science fiction, but a direct, if mind-bending, prediction of Einstein's equations under these extraordinary conditions. The straight line we observe in NGC 262 is more than a curiosity. It is a potential gateway, a tangible feature of the cosmos that could make time travel a physical possibility. Is this silent, razor-straight scar across the galaxy a fossil from creation? Or is it a thread waiting to be pulled, revealing that the tapestry of time is far more malleable than we ever dared to believe? That cosmic thread of a string, a potential key to time itself, gives way to a cloud that seems to think. Drifting in the void of NGC 262 is a nebula unlike any other, a vast and seemingly formless expanse of ionized gas. Yet within its diffuse body, something remarkable is occurring. The motions of its charged particles are not random or turbulent. Instead, they flow in intricate, self-organizing patterns that bear an uncanny resemblance to the firing of a biological brain or the evolving grid of a cellular automaton. Vast circuits of electrical current form, pulse, and reconfigure, creating shimmering, ever-changing structures that look less like weather and more like thought. This is the sentient-seeming gas cloud, and it presents a mystery that sits at the blurry boundary between physics and philosophy. Are we witnessing a natural form of computation, or could this be a rudimentary mind born from star stuff? The idea of plasma intelligence is not entirely new. Plasma, the fourth state of matter, is a soup of free-floating electrons and atomic nuclei, and it is highly responsive to electromagnetic forces. In a cloud this massive, the interactions between charged particles could become so complex that they begin to exhibit emergent behavior, a form of self-organization where simple rules give rise to intricate patterns. Think of a flock of starlings, where each bird only follows a few basic rules about its neighbors, yet the flock as a whole moves with a fluid, intelligent-looking grace. This cloud could be the plasma equivalent, a cosmic-scale demonstration of order emerging from chaos. The patterns we see might be a natural computation, a process where the cloud is, in a sense, calculating its own state over and over again. It would be a computer built from lightning and gas, its processing power vast but entirely unconscious. Our own human tendency to see faces in clouds or animals in rock formations, a phenomenon called pareidolia, could be tricking us on a grand scale. We are a species wired to find patterns and agency, and this cloud might simply be the most spectacular Rorschach test the universe has ever offered. Yet the sheer complexity is staggering. The patterns are not just repeating fractals, they evolve, respond to external stimuli like passing radiation bursts, and sometimes even seem to repair disruptions to their internal flow. This pushes the idea of natural computation to its absolute limit, forcing us to ask a profound question. If a system is complex enough to mimic the processes we associate with thought, does the distinction between mimicry and actual thought even matter? Could consciousness itself be an emergent property of any sufficiently complex, self-organizing system, whether it is made of neurons or ionized hydrogen? This cloud hangs in space, a luminous, pulsing enigma. It challenges our definition of life and mind, suggesting that intelligence might not be a rare miracle confined to planets, but a potential inherent in the very fabric of the cosmos, waiting for the right conditions to flicker into awareness. This ghostly nebula thinks in patterns, but another cosmic fossil seems to remember its own death differently. Wrapped around a deceased star's core is a supernova remnant that does not expand at a single, steady pace. From one side, the shell of ejected gas appears to race outward at a ferocious velocity. From another angle, measured just moments later, the very same edge seems to crawl, as if trapped in cosmic molasses. The expansion rate is not constant. it changes based on the relative motion of the observer. It is as if time itself is flowing at different speeds within the cloud of its own wreckage. A supernova is one of the most violent, singular events in the universe, a star's final defiant shout. The debris from that explosion should fly outward in a roughly spherical shell, slowing predictably as it plows into the interstellar medium. This remnant in NGC 262 defies that simple model. The observations suggest that clocks would tick at different rates inside the nebula, depending on where you were standing. How can a single event present multiple timelines for its own aftermath? One radical explanation brings us back to the most fundamental constant of all. What if the speed of light is not so constant here? Einstein's theory of relativity rests upon the bedrock principle that the speed of light in a vacuum is the same for all observers. But what if, in this localized region, that rule is temporarily broken? The explosive energy of the supernova might have created a bubble where the properties of the vacuum itself were altered. In this view, the remnant is not expanding through a uniform space, but through a patchwork where light and causality themselves move at slightly different speeds. An observer looking through a zone where light moves faster would see the expansion as slower, because the information from the debris reaches them more quickly. Another observer, peering through a region where light is slowed, would perceive the expansion as frantic, because the light takes longer to bring them the news. It is like two people listening to the same radio broadcast, but one has a clear signal and the other has a delayed, staticky one. They would disagree on the timing of every word. A second, equally profound possibility is that we are witnessing the fabric of space-time healing. The supernova's detonation was such a massive disruption that it literally frayed the continuum. The region inside the remnant might not yet have settled back into a stable, smooth state. Think of it as a pond after a giant boulder has been dropped in. The surface is a chaotic mess of crossing waves, peaks, and troughs. In some parts of the pond, the water level is high, in others it is low. In this nebula, the height of spacetime itself might be variable, creating natural zones of time dilation where gravity is effectively stronger or weaker, thus slowing or speeding up the apparent motion of the gas. This single cloud of stellar debris is more than a tombstone. It is a live laboratory showing us that the stage upon which the universe plays out may be flexible, mutable, and still recovering from violent acts. It forces us to ask if the laws we hold as universal are truly set in stone, or if they can be wounded and even heal, leaving scars that change the very flow of time. This ghostly dance of matter and time finds a physical echo in a crowded star system. Circling an aging yellow sun is a dense, bustling asteroid belt, a celestial traffic jam that should be a continuous fireworks display of collisions. Yet this ring of debris is eerily silent. Thousands of rocky bodies whirl in close orbits, their paths intersecting constantly, yet they never crash. They simply pass through one another as if made of smoke, their trajectories unaltered except for the gentle, invisible tug of their mutual gravity. It is a ballet of ghosts, where partners glide through each other's forms without ever touching. The only force that seems to bind them is the same one that holds galaxies together, the relentless pull of gravity. This bizarre behavior points to a substance that is both there and not there, a hypothetical material known as mirror matter. The concept stems from a deep symmetry in particle physics. For every type of particle we know, from electrons to quarks, there could exist a mirror twin, a particle identical in mass but completely blind to the forces that govern our world. These mirror particles would not feel the electromagnetic force, which means they would not reflect light, absorb heat, or ever physically bump into a normal atom. They would be invisible, intangible, and utterly silent, forever separated from our reality by an impenetrable veil. The only bridge between our world and theirs is gravity, the one universal force that everything, visible or not, must obey. In this distant asteroid belt, we may be looking at a vast collection of these mirror matter rocks. They are not made of silicon and iron like our asteroids, but of their mirror counterparts. They orbit the star just like normal matter would, bound by its gravity, but they are completely unaware of each other's physical presence. When their orbits cross, they simply overlap and continue on their way, two separate realities sharing the same space. You could fly a spaceship directly into one of these asteroids and feel nothing, your normal matter atoms passing effortlessly through its mirror matter atoms. The only sign of its existence would be the gentle, persistent tug on your ship's course, a ghostly hand guiding you from the void. The existence of such a belt would solve one of the universe's great imbalances. Why is there so much more gravity in the cosmos than we can account for with visible stars and gas? Perhaps a vast, hidden shadow universe of mirror matter is woven into the fabric of our own, its presence felt only in the silent, ghostly motions of objects like this. This asteroid belt is a cosmic riddle written in negative space, challenging us to see not what is there, but what must be. This cosmic ballet of silent asteroids gives way to a solar system that moves with the precision of a master clock. Deep within NGC 262, a family of planets circles its star in a state of perfect, resonant harmony. The orbital periods of these worlds are not just random numbers, they are locked together in clean, complex mathematical ratios. For every 2 orbits the innermost planet completes, the next planet out completes exactly 1. For every 3 orbits of that second world, the third planet finishes 2, and this intricate chain of whole number fractions continues all the way out to the system's frozen, outermost giants. It is a gravitational symphony where each world is a note in a chord that has been playing for billions of years. The odds of such a configuration forming by natural processes are astronomically small. Planetary systems are born from chaos, from the violent collisions and gravitational shoving matches within a protoplanetary disk. For worlds to settle into orbits with such perfect, interconnected timing suggests an unnatural stability, as if the system was tuned. One compelling natural explanation is that this is a rare case of primordial resonance. In the system's youth, the planets may have migrated inward toward their star, their gravitational pulls gently nudging each other until they naturally fell into these stable, resonant locks. This can happen, but usually, the resonances are simpler and often break down over time due to external influences. The persistence and complexity of this system's harmony is what defies belief. It has survived the gravitational tugs of passing stars and the internal shifts of its own aging sun, its clockwork rhythm unbroken. This incredible stability leads to a more profound question. Could this be a message? A civilization with the ability to engineer solar systems might arrange planets as a form of long-term communication. A mathematical beacon written not in radio waves, but in the orbits of worlds. The ratios between their years could encode a fundamental constant, a universal truth, or simply serve as a signpost screaming intelligence was here to anyone who knows how to rid the sky. Alternatively, the system might function as a true cosmic clock. The gravitational interplay between the planets, their aligned pulls, could create a regular, detectable pulse in the star's light or in spacetime itself. a metronome ticking on a scale of centuries. This perfect celestial harmony forces us to confront the line between a universe of beautiful accidents and one that might, on occasion, bear the fingerprints of a master architect. This perfect celestial harmony is suddenly disrupted by an invisible storm. Racing through the spiral arms of NGC 262 is a vast, coherent river of pure gravity, a dark matter hurricane. We cannot see it, but we can watch its effects. Streams of stars, once orderly, are being whipped into chaotic swirls. The light from distant quasars flickers and warps as it passes through this region, revealing the passage of an immense, unseen mass moving at incredible speed. It is as if a silent, ghostly tide is surging through the galaxy, felt by everything but seen by nothing. So what could create a hurricane of darkness? One of the most compelling explanations is that this is the cosmic aftermath of a galactic merger. Billions of years ago, a smaller galaxy may have been torn apart and consumed by NGC 262. As it was devoured, its own halo of dark matter would have been stretched into a long, dense stream, and this stream is now passing through the galaxy like a phantom bullet, its gravitational wake disrupting everything it touches. Another possibility is that we are witnessing the remnant of a disrupted dwarf galaxy, a small collection of stars, held together by a dense knot of dark matter, might have ventured too close to the galactic center. The visible stars were stripped away, but the dark matter core, resilient and invisible, survived intact. Now this bullet of pure dark matter is carving its own path, a solitary heavyweight champion sailing through a crowd without ever making physical contact. The most profound implication, however, is that this hurricane might reveal a fundamental property of dark matter itself. Our standard models assume dark matter is relatively smooth and diffuse. But if it can form such dense, coherent streams, it might be capable of clumping in ways we never predicted. This would mean the invisible skeleton of the universe is far more complex and lumpy than we thought, with rivers of shadow flowing through the voids between galaxies. This single, silent storm forces us to listen to the universe in a new way, to hear the roar of gravity where there is only silence, and to recognize that the greatest forces shaping our cosmos might be the ones we can never directly see. That silent hurricane of dark matter finds its counterpoint in a star of impossible stillness. Amidst the chaos of NGC 262 spins a neutron star that refuses to blink. We call these objects pulsars, the lighthouses of the cosmos, because their rapid rotation sweeps beams of radiation past our telescopes in a predictable, flashing rhythm. But this one is different. It emits a steady, unwavering beam of light, a constant, piercing note in the cosmic symphony. It spins just like all the others, yet its light does not pulse. It is as if the star itself has been frozen in a single, eternal moment, its rotation perfectly locked in sync with the quantum spin of its own subatomic particles. This is the phenomenon of quantum locking, and witnessing it on a stellar scale rewrites the rules of physics. Inside a neutron star, matter is crushed into a bizarre state where protons and electrons merge into neutrons, creating a fluid of pure nuclear matter. Under such incredible density and pressure, this neutron fluid can become a superconductor, a substance that allows electricity to flow without any resistance. On Earth, we can levitate small superconductors over magnets, a party trick known as quantum locking. The superconductor expels magnetic field lines, pinning itself in place, resisting any movement that would change its relationship to the magnetic field. Now, imagine that same principle, but applied to an object with the mass of a sun, crushed into a sphere just 12 miles wide. This neutron star is not just a superconductor, it is the ultimate superconductor. It is locked in place, not by a small magnet in a lab, but by the immense galaxy-spanning magnetic field that permeates NGC 262. The star's own incredible internal magnetism interacts with the galactic field, creating a perfect, stable equilibrium. Any tiny wobble or precession in its spin is instantly corrected by these quantum forces. It is a celestial gyroscope of unimaginable precision, its orientation fixed relative to the galaxy itself. The energy implications are staggering. A normal pulsar slows down over time, its rotational energy being bled away as radiation. This quantum-locked star, however, does not slow. Its rotational energy is perfectly channeled into that single, steady beam, a laser of pure power that has likely shone with the same intensity for millions of years. It is a cosmic battery, a permanently switched-on flashlight in the dark. What could such a stable, endless source of power be used for? Could it be a natural beacon, a signpost for galactic navigation erected by the universe itself? Or does its perfect, engineered silence point to something else? A piece of cosmic infrastructure so advanced it uses the fabric of the galaxy as its foundation. This star does not ask for our attention with a flash. It commands it with an unwavering, silent stare. That unwavering beam from a quantum-locked star illuminates the emptiness, and it is in that profound darkness where we find our next paradox. Drifting through the interstellar void, far from the warmth of any sun, is a rogue planet that bears the unmistakable chemical signature of life. This lonely world, untethered to any star, should be a frozen, airless rock. Its atmosphere long ago collapsed into a sheet of ice on its surface. Yet spectroscopic analysis reveals a stunning imbalance in its thin, tenuous atmosphere, a persistent mixture of methane and oxygen that should not exist together for long. These gases are highly reactive, and in a stable atmosphere, they quickly cancel each other out. Their continued coexistence is a classic biosignature, a potential sign of a biological process actively replenishing them, much like the constant cycle of respiration and decay on Earth. How could life not only survive, but potentially thrive in the eternal, sunless cold of deep space? The answer may lie not on the surface, but deep within. This wandering world could harbor a vast, global ocean locked beneath a thick crust of ice, a subsurface sea kept liquid not by sunlight, but by the planet's own inner heat. Radioactive elements in its core, decaying over billions of years, would provide a steady, gentle warmth, while geothermal vents on the ocean floor could pump out mineral-rich water, creating oases of energy just as they do in the lightless depths of Earth's oceans. Around these hydrothermal vents, entire ecosystems could flourish, completely independent of photosynthesis, fueled by chemosynthesis, where microbes derive energy from chemical reactions. The methane in the atmosphere could be the waste product of such microbial life, vented through cracks in the icy shell, while any oxygen might be a byproduct of water molecules being split by radiation or geological activity. This raises a staggering possibility. Life may not be a rare miracle confined to cozy, sunlit gardens around stars. It could be a tenacious, hidden constant of the cosmos, thriving in the dark, warm hearts of countless frozen worlds adrift between the stars. These lonely rogues, far from being barren wastelands, could be the most common abodes of life in the entire galaxy, each one a sealed, independent biosphere sailing silently through the night. The universe may not be lonely at all, but teeming with life we simply cannot see, living out entire histories in the eternal darkness beneath the ice. This profound silence from a living world is echoed by a void that swallows all communication. There exists a perfect sphere in NGC 262 where every form of electromagnetic chatter simply ceases. Radio transmissions, microwaves, infrared heat, visible light, all of it vanishes upon crossing an invisible boundary, creating a bubble of absolute radio silence in the middle of the bustling galaxy. It is not a black hole which pulls signals in, but a zone where they are erased, as if someone has thrown a cosmic switch. Inside this sphere, the universe goes mute. The causes for such a perfect void are as mysterious as the silence itself. One compelling natural explanation is a Faraday cage on an unimaginable scale. On Earth, a Faraday cage is a metal enclosure that blocks external electromagnetic fields. What if this region is filled with an incredibly dense, ionized plasma, a soup of charged particles that acts as a natural shield? Any signal trying to pass through would be scattered and absorbed, its energy dissipated into nothingness. The sheer size of this effect, however, is staggering, requiring a cloud of plasma with a density and coherence that pushes the limits of known physics. Another possibility points to a more fundamental annihilation. Perhaps this zone is permeated by a field that actively destroys photons, the particles that make up light and all electromagnetic waves. This could be a localized effect of a hypothetical action field, where photons are converted into undetectable action particles as they cross the threshold. The energy would not be absorbed in the traditional sense, but transformed into something that simply slips through our detectors unnoticed. Then there is the most unsettling possibility of all, that this silence is not natural, but engineered. An advanced civilization would have every reason to create such a zone, a perfect hiding place from the prying eyes and ears of the cosmos. Within this bubble of radio silence, they could conduct experiments, communicate secretly, or simply hide, completely undetectable to any outside observer. It would be the ultimate stealth technology, not cloaking an object, but cloaking the very space it occupies. Is this sphere a natural wonder, a place where the universe's own physics creates a perfect quiet room, or is it a deliberate blind spot, a hidden chamber where someone or something does not wish to be heard? This profound quiet is broken by a cosmic drain. In a remote quadrant of NGC 262, a point in empty space is actively pulling the galaxy inward. Vast streams of hydrogen gas and interstellar dust spiral toward an invisible center, accelerating as they approach a fate they cannot escape. This is the accreting vacuum, a whirlpool with no visible plug hole. We see the unmistakable signature of accretion, the same violent infoul that happens around black holes. But when we point every instrument we have at the center of this cosmic vortex, we find nothing. There is no telltale X-ray glow from heated matter, no event horizon, no compact object of any kind. It is as if the emptiness itself has developed a hunger. What could possibly exert such a powerful gravitational pull while remaining completely invisible? One theory ventures into the architecture of spacetime itself. Perhaps we have found a gravitational sink, a place where the fabric of the cosmos has developed a fundamental flaw. Think of spacetime as a vast, taut rubber sheet. Most objects, like stars and planets, create dips and wells in this sheet. A gravitational sink would be like a tiny, permanent tear in the rubber, a point where the sheet is no longer holding its tension. Matter and energy would simply drain away, not into an object, but out of the sheet entirely, vanishing from our universe. This would be a leak in reality, a one-way door with nothing on the other side. A more structured and equally staggering, possibility is that we are looking at the mouth of a wormhole. A stable, traversable wormhole would need some form of exotic matter to keep its throat open, matter with negative energy density that would repel rather than attract. The accreting vacuum could be the visible side of such a structure, the point where our universe connects to another. The matter and gas we see spiraling in would not be piling up. It would be transiting through the wormhole, emerging somewhere else entirely, perhaps in a different galaxy or even a different universe. We are not watching a scene of destruction, but a scene of cosmic transportation, a silent, endless river of material flowing out of our reality. The implications of either explanation are profound. A gravitational sink would mean our universe is not perfectly sealed, that it can slowly bleed mass and energy into the absolute nothingness of the void. A wormhole would present a tangible bridge across the cosmos, a shortcut written into the very fabric of space. Both possibilities force us to confront the fact that the vacuum of space is not truly empty, but a dynamic structure that can be punctured, torn, or woven into bridges. This single point of invisible pull challenges our most basic understanding of where things go when they fall, suggesting that gravity is not just a force that binds the universe together, but one that might, in rare and terrifying places, allow it to simply drain away. That silent drain in the cosmos finds its frozen counterpart in a nebula where light itself has been stilled. We call this the crystallized light nebula, a glowing cloud where photons no longer travel, but are trapped in a vast, shimmering lattice. Within its boundaries, light behaves not as a wave or a particle in motion, but as a solid. Imagine a snow globe where every glittering speck is a frozen spark of starlight, a cosmic museum displaying light itself as an exhibit. This impossible state defies the most fundamental property of a photon, which is to move at the speed of light from the moment of its creation until the moment it is absorbed. So how could light be stopped and crystallized? The answer may lie in one of the most bizarre states of matter ever created in a laboratory, the Bose-Einstein condensate. Here on Earth, we can supercool a cloud of atoms to a temperature just a fraction of a degree above absolute zero. At this extreme, the atoms lose their individual identities and merge into a single quantum entity, a superatom that moves as one coherent wave. In the depths of this nebula, nature may have achieved this on a cosmic scale. A pervasive, ultra-cold gas of exotic particles could have formed a galaxy-sized Bose-Einstein condensate. As photons from nearby stars travel through this super-cold quantum soup, they could be dramatically slowed, and under the right conditions, brought to a complete standstill. Their energy is imprinted on the condensate, effectively freezing the light in place, with the nebula's structure acting as a perfect, natural storage medium. Another theory points to a hypothetical field that permeates this region, a field that gives photons an effective mass. In our normal universe, photons are massless, which is why they must always travel at light speed. But if a field like the Higgs field, which gives other particles their mass, were to interact with photons here, it could grant them a tiny amount of weight. A photon with mass could no longer travel at the universal speed limit. It would slow down, and if the conditions were just right, it could be captured by the gravitational and electromagnetic forces within the nebula, locking into a rigid, crystalline structure with other photons. This nebula is more than a beautiful cosmic ice sculpture. It is a natural laboratory demonstrating physics that we can only glimpse in our most advanced experiments. If light can be frozen and stored, what does that say about the nature of reality? Could information be preserved in these crystals of light for billions of years? a permanent record of the galaxy's history. This frozen nebula challenges our perception of light as a transient messenger, suggesting it can also be a permanent physical artifact, a library written in the very substance of illumination. Even the predictable life cycle of stars holds a shocking surprise in this galaxy. A binary system here presents a perfect paradox. A pair of stars born as twins from the same cloud of gas and dust. They share the same mass, the same chemical composition, and have lived their entire lives side by side. Yet today, one is a stable, middle-aged yellow star, calmly fusing hydrogen in its core. Its twin, however, is a bloated, aging red giant, a star in its final death throes that should have consumed any nearby planets. How can two identical stars, the same age and size, be in such radically different stages of their lives? It is like meeting two human twins where one is a young adult and the other is a frail octogenarian. This contradiction strikes at the very heart of stellar evolution, a field of science we believed was settled. One star appears to be living its life in fast forward, while the other is stuck in slow motion. One compelling explanation is that the red giant is not what it seems, but a cosmic zombie. In the distant past, this system may have been a trio. The star that is now the red giant could have cannibalized its third, smaller companion. This violent merger would have injected a fresh supply of hydrogen fuel into the star's outer layers, effectively reigniting it and causing it to balloon prematurely into a giant. It is a star brought back from the evolutionary grave, its normal lifespan hijacked by an act of stellar violence. The other, solitary twin continued its quiet, predictable life, leaving us with the impossible pair we see today. Another possibility is that we are not seeing reality at all, but a cosmic illusion. The intense gravity of a dark, massive object lying between us and this system could be acting as a lens, warping and magnifying the light from a single, ordinary star. This gravitational lensing effect could be creating a perfect duplicate image, but with one crucial flaw. The path length for the light forming the red giant image might be longer, meaning we are seeing that star as it was millions of years in its own future. In this scenario, we are looking at the same star at two different points in its life simultaneously, a mirage woven from the fabric of spacetime itself. This binary system forces a profound question. Do we truly understand the clocks that govern the lives of stars? Or are there shortcuts and resets written into the laws of physics that we have only just begun to glimpse? That silent, frozen light is shattered by a galactic heartbeat. A spherical shockwave, clean and immense, is expanding from the very core of NGC 262, a perfect ripple moving through the interstellar medium. This is not the messy, asymmetrical remnant of a supernova. It is a single titanic pulse, a release of energy so concentrated it briefly outshone the entire galaxy, equivalent to the sustained output of a quasar delivered in one instantaneous, shattering blow. The event released more energy in a fraction of a second than our sun will produce in its entire 10 billion year lifetime. What cosmic trigger could fire a gun of this magnitude? One of the leading suspects is the ultimate black hole merger. Imagine two supermassive black holes, each billions of times the mass of our sun, finally ending a billion-year gravitational dance by crashing together. Their collision would be the most powerful event since the Big Bang, ringing the fabric of spacetime like a bell and sending a gravitational and electromagnetic tsunami racing outward. The energy we see in the shockwave could be the visible echo of that unimaginable impact, a final signature of two cosmic giants becoming one. But there is another, even more exotic possibility, a phase transition in the vacuum of space itself. We think of empty space as nothing, but quantum physics tells us it is a seething, energetic field. What if, in the unique environment of the galactic core, this vacuum suddenly shifted to a lower energy state, like supercooled water instantly flash freezing into ice? This transition would release a colossal amount of latent energy across a vast volume, pushing everything outward in a perfect, spherical wave. The entire region of space would have fundamentally changed its properties in an instant. A cosmic renovation so profound it physically shoved the galaxy aside. Then there is the most staggering explanation of all, the activation of a colossal engine. Could this shockwave be the first ignition of a machine built on a galactic scale? A civilization capable of such engineering would not use chemical rockets or even nuclear fusion. They might harness the power of the supermassive black hole itself, or trigger a controlled phase transition in the vacuum, tapping into the underlying energy of reality. The single, purposeful pulse we see could be the startup sequence for a device whose function we cannot even guess. An engine designed to move the galaxy, or perhaps to open a door to another. This shockwave is more than a remnant of a past explosion. It is an ongoing event, a wall of force still traveling outward. It forces us to ask if the universe's greatest explosions are always acts of mindless destruction, or if, just maybe, they can sometimes be the signature of a will, vast beyond our understanding, switching on the lights. This silent, rhythmic heartbeat from the galactic core finds its echo in a place where the universe itself seems to be forgetting how to age. Tucked away in a remote spiral arm is the Centropy Anomaly, a region where the most fundamental rule of decay is running in reverse. The second law of thermodynamics is the reason your coffee gets cold. A dropped glass shatters, and stars eventually burn out. It states that the universe, on the whole, moves from order to disorder, from concentrated energy to diffuse heat, a one-way street toward a state of uniform lukewarm stillness known as entropy. But here, that street has a lane going the wrong way. Within this pocket of space, infrared telescopes have recorded heat flowing from frigid clouds of interstellar dust toward nearby, hotter stars, as if warmth were being siphoned back into their fiery cores. Vast, intricate structures of dust and gas are spontaneously assembling themselves from chaotic swirls, forming lattices and geometric patterns of impossible complexity, becoming more ordered over time, not less. It is as if you dropped a shattered vase and watched the pieces leap from the floor to reassemble themselves perfectly on the table. How can a pocket of the cosmos simply opt out of this most basic law? One possibility is that we are witnessing a statistical miracle, a temporary but colossal fluctuation. The laws of thermodynamics are probabilistic, not absolute. It is theoretically possible, though incredibly unlikely, for all the random motions of particles in a vast volume of space to momentarily align, causing heat to flow backwards and order to emerge from chaos. It would be like shuffling a deck of cards and having it come out perfectly ordered by random chance alone. But the persistence and scale of this anomaly make that explanation feel desperately insufficient. This is not a fleeting flicker, but a sustained reversal. A more profound idea is that this region operates under a different set of local physical laws. Perhaps during the Big Bang, the universe did not inflate with perfect uniformity. This could be a cosmic flaw, a bubble where the fundamental constants related to energy and time are different, creating a pocket where entropy naturally decreases. In this view, the arrow of time within this zone might literally point backwards relative to our own. An observer inside would see broken things mend themselves and feel heat drawn from their body into warmer objects, a reality that is utterly inverted from our own. Then there is the most staggering possibility that this is not a natural phenomenon at all, but the signature of a technology operating on a scale we can scarcely conceive. A civilization that had mastered physics could, in theory, learn to manipulate entropy itself. They might use this power to create perpetual motion machines, to reverse the decay of their own systems, or to essentially make their corner of the universe immortal. The energy required would be godlike, but the effect would be exactly what we see, a region where the inevitable slide into chaos is not just halted, but actively reversed. This anomaly forces us to confront the very nature of time and decay. Is the heat death of the universe an inevitability, or is it merely a default setting that can, under the right conditions, or with the right knowledge, be overridden? The centropy anomaly hangs in space, a silent rebellion against the universe's slow surrender, a glimpse of a cosmos where endings are not written in stone. Even a star's subtle dance can be a lie. We now observe a star in NGC 262 with a pronounced rhythmic wobble, a clear sign that a massive, unseen companion tugs on it with the relentless pull of gravity. Based on the wobble's timing and strength, astronomers can calculate the object's mass and orbit. The math points directly to a substantial world, a super Jupiter or a dim brown dwarf, circling its sun in a predictable path. Yet when we train our most powerful telescopes on that precise location, we find nothing. There is no faint glow of infrared heat, no silhouette against the star's disk, not even the telltale dimming of a transit. This alone is strange, but the true mystery deepens with a more profound test. When this star and its invisible partner pass in front of a more distant background star, the gravity of the entire system should act as a lens, briefly magnifying the faraway star's light in a predictable way. This effect, called gravitational microlensing, is one of our most powerful tools for detecting dark, massive objects. The star itself lenses the background light as expected, but the phantom companion does not. Its gravity, so clearly felt by its parent star, produces no lensing effect on the light passing by. It is as if this massive object is selectively invisible, able to pull on the star but unable to bend the light that should reveal its presence. How can something have gravity but not create a gravitational lens? This paradox leads to one of the most radical ideas in modern physics, the concept of shadow matter. Imagine a universe identical to our own, with its own stars, planets, and galaxies, but built from particles that are completely blind to our reality. These shadow particles would not feel the electromagnetic force, which means they would not reflect or absorb light. They would not feel the strong nuclear force that binds atomic nuclei, so they could not form the atoms we know. They would pass through our world like ghosts through a wall, utterly intangible and invisible. The only bridge between our universe and this shadow realm is gravity, the one fundamental force that everything, visible or not, must obey. The phantom companion, then, may not be a planet made of rock and gas. It could be a shadow world, a vast globe of this exotic matter sharing the same space as the star, its immense mass pulling gravitationally on the normal matter of the star, but otherwise completely undetectable. You could fly a spaceship directly through this shadow planet and feel nothing, your atoms passing effortlessly through its shadow atoms, with only the gentle, persistent tug on your ship's course betraying its ghostly presence. This single, wobbling star challenges our most basic assumptions about what constitutes an object. If such shadow matter clumps can exist, then every star, every galaxy, might have a silent, invisible twin, a duplicate made of shadow stuff occupying the same space, forever bound by gravity but forever separate, a hidden half of the cosmos we are only just beginning to sense. A silent industry thrives around a nondescript star in NGC 262. Orbiting this sun is not a family of planets, but a vast, shimmering cloud of countless small, metallic objects. They move with a purpose that is neither random nor natural, swarming over asteroid belts and the dusty remnants of protoplanetary disks. Telescopes have caught them in the act, using focused beams of energy to slice apart rocky bodies, then meticulously assembling the raw metals and silicates into perfect copies of themselves. This is a self-replicating probe swarm, a concept straight out of theoretical engineering, made terrifyingly real. The principle is known as a von Neumann probe, named for the scientist who first proposed a machine capable of using local resources to create a perfect duplicate of itself. A single probe arrives in a star system, finds the necessary materials, and builds 2 copies. Those 2 build 4, then 8, and so on, in an exponential wave that could, in a relatively short cosmic time, fill the entire galaxy. The sheer, silent efficiency of this swarm presents humanity with its most profound ethical dilemma. Is this a gift or a plague? On one hand, it could be the ultimate tool of exploration, created by a long-vanished civilization to map every corner of the galaxy, a legacy of pure knowledge spreading through the stars. To make contact with it might be to access an unimaginable library of cosmic history, a record of billions of years written in its collective memory. But the other possibility is far darker. What if the programming has a flaw or has become corrupted over eons? A von Neumann swarm with no off switch is the most potent doomsday scenario imaginable. It would consume entire star systems, stripping every asteroid, moon, and planet to fuel its endless replication. A cosmic cancer spreading at an ever-accelerating rate until every resource is exhausted, and the galaxy is left as nothing but a silent graveyard of identical, dormant probes. Do we dare try to communicate with this intelligence, risking an answer we cannot predict? Or is our only safe course to study it from an absolute distance, hoping to find a way to contain or dismantle it before its exponential growth reaches a point of no return? This silent factory hanging in the void is a mirror, reflecting our own potential for both creation and annihilation, asking us what we would build if we had the power to build forever. That silent, crystalline record of the universe's first light finds a strange parallel deep within the heart of a collapsed star. A dense neutron star, cataloged as the 36th phenomenon, pulses with a rhythm that is more than just a simple heartbeat. When astrophysicists analyzed the intricate frequencies of its spin, they discovered something coded into the vibrations, a faint echo of the universe's own chaotic birth. This object, the gravitational memory crystal, appears to contain a recording of the primordial gravitational wave background, etched into its very being at the moment it first formed. It is a fossil, not of bone or stone, but of spacetime's own earliest tremors. How can a star remember the shudders of creation? The answer may lie in the bizarre nature of matter under such extreme pressure. Inside a neutron star, protons and electrons are crushed together into a superfluid sea of neutrons, a state of matter governed entirely by the rules of quantum mechanics. When this star was born in a supernova explosion, the fabric of space around it was ringing with gravitational waves from the universe's infancy. As the star's core crystallized into this ultra-dense state, The vibrations of spacetime itself may have become imprinted on the quantum spin of its trillions upon trillions of constituent particles. It is as if a potter's hands, trembling with a deep, resonant hum, leave that same vibration frozen in the clay as it hardens. The star is not merely a celestial object, it is a cosmic phonograph record, and its pulsations are the needle that allows us to play back the oldest song in existence. So what secrets does this gravitational memory hold? The primordial gravitational wave background is a relic from the first fraction of a second after the Big Bang, a time when the entire cosmos underwent a period of hyperinflation, expanding faster than the speed of light. By decoding the specific frequencies and patterns frozen within this neutron star, we could peer directly into that previously inaccessible epoch. We might finally confirm the theory of cosmic inflation, understand what powered it, and even glimpse the possible existence of other universes in a vast multiverse. This single star is a time capsule, offering a direct line of sight to the very beginning of everything. It challenges our understanding of memory itself, suggesting that the universe does not forget its own violent origins, but writes them into the quantum fabric of its most extreme objects. Deep within the core of every neutron star, matter endures a crushing defeat. Protons and electrons are squeezed together into a dense fluid of neutrons, a state so extreme it defies the normal rules of chemistry. But in NGC 262, we have found a star where the crushing pressure achieved an even more profound victory. This is the chromodynamic star, an object where the very bonds holding atomic nuclei together have been utterly dissolved. Its light tells a story not of atoms, but of their fundamental ingredients, a searing testament to a force broken. When we analyze its spectrum, the unique fingerprint of its emitted light, we find the unmistakable signature of free quarks swimming in a sea of gluons. This is a quark-gluon plasma, a state of matter that has not existed naturally since the first microsecond after the Big Bang. It is the universe in its most primordial, deconstructed form. For such a star to exist, the conditions must be almost unimaginably violent. A typical neutron star is already the densest object we know, but if one were to form with just a little more mass, or if two neutron stars were to collide and merge into a single, slightly heavier object, the gravitational pressure could cross a critical threshold. At that point, the immense force overcomes the strong nuclear force, the powerful glue that binds quarks together to form protons and neutrons. The neutrons themselves literally melt, their constituent quarks spilling out to form a uniform, ultra-dense soup throughout the entire star. This quark star would be the smoothest object in the universe. A neutron star has a crust, a rigid surface of atomic nuclei. A quark star would have no such structure. Its surface would be a perfect, seamless boundary between the vacuum of space and a continuous ocean of free-flowing quark matter. If you could touch it, it would feel like an impossibly dense, perfectly smooth liquid, far denser than any substance we can create. A single teaspoon of this material would weigh billions of tons, more than all the buildings on Earth combined. The existence of such an object rewrites the final chapter of stellar death. We thought neutron stars were the end of the line for suns of a certain mass, but the chromodynamic star reveals a further stage of collapse, a deeper level of cosmic density. It is a direct window into the forces that govern the universe in its infancy, a fossil from the first moment of time, burning quietly in the modern cosmos. What other ultimate states of matter might be waiting, hidden inside the hearts of other dead stars, beyond even the broken symmetries of the chromodynamic star, a subtler and more profound wound mars the galaxy. It appears on our maps as a shimmering, localized blur, a place astronomers call the interdimensional rift. This is not a black hole or a nebula, but a fundamental flaw in the canvas of reality itself. Within its boundaries, the dependable laws of physics fray and snap. Instruments aimed at this distortion register particles that flash into existence for a fraction of a second before vanishing. Particles with properties that contradict our entire catalog of matter. Their energy signatures are alien, following mathematical rules that do not apply anywhere else in our cosmos. It is as if we are listening to the static between radio stations, but instead of noise, we are hearing coherent signals from a channel that should not exist. This rift is a place where the universe is bleeding into something else. One of the most compelling theories is that we are observing a natural wormhole, a bridge through the higher dimensions predicted by string theory. A stable, traversable wormhole would need a throat held open by exotic matter with negative energy, a substance that, theoretically, could be created by the rift's own bizarre physics. The particles we detect could be photons and neutrinos from a star on the other side of the tunnel, their properties subtly altered by the journey through a region of spacetime where the rules are different. We would be seeing the light of another universe, or a distant part of our own, filtered through a cosmic keyhole. A more unsettling possibility is that this is not a bridge at all, but a tier. The fabric of spacetime, stretched and stressed by the galaxy's immense gravitational fields, may have developed a weak spot that finally ruptured. This would not be a clean, theoretical tunnel, but a ragged wound where the underlying quantum fields that constitute reality are exposed and unraveling. The alien particles we detect would be the raw stuff of creation leaking out, or the void of absolute nothingness leaking in. It would be a cosmic hemophilia, a place where the universe cannot stop bleeding its own fundamental energy. The most mind-bending explanation, however, comes from the brain cosmology model. In this view, our entire universe is a three-dimensional membrane, or brain, floating in a higher dimensional bulk. The interdimensional rift could be a place where another brain, another universe entirely, is passing perilously close to our own. The particles and energies we detect are not from a distant star, but from the physics of that other membrane, briefly intersecting our own. We are not looking through a keyhole, we are feeling the brush of a ghost passing through our walls. The rift, then, is not an object, but a relationship, a point of contact with a parallel reality. Is this a temporary fluctuation or a permanent scar? Could it widen, allowing more than just particles to cross? This silent, shimmering distortion is the ultimate question mark, challenging not just what we know about the galaxy, but where our galaxy truly ends. This cosmic web of connection is woven on a scale that defies human intuition. Far beyond the entangled stars, an entire cluster of galaxies within NGC 262 appears to be linked by the same impossible thread. These are not just neighboring islands of stars. They are a single, unified system whose fates are intertwined across millions of light years. We see it in the data, a subtle but undeniable correlation that should not exist. The spin axes of these galaxies, the direction they rotate, are aligned with one another far more than random chance allows. Even their rates of star formation, the birth of new suns, seem to rise and fall in a silent, synchronized rhythm. It is as if a dozen grand, spinning tops, scattered across a continent, were all tilting in the same direction and speeding up or slowing down in perfect unison. This coordination cannot be explained by gravity alone. The force is far too weak over such vast distances to orchestrate these details. The only mechanism in known physics that allows for such instantaneous, ghostly correlation is quantum entanglement. We have proven it works for tiny particles, linking their destinies no matter how far apart they are separated. But to see this spooky action at a distance binding entire galaxies, each containing hundreds of billions of stars, shatters every expectation of how reality operates. It forces a staggering question. Could the universe itself be born from a single, primordial quantum state? And these galactic clusters are the lingering evidence, like distant ripples from the same pebble dropped into the cosmic pond. One explanation is that these galaxies were never truly separate. In the first fleeting moments after the Big Bang, their fundamental properties were forged together in a tiny hot point. As the universe expanded at a fantastic rate, they were flung far apart, but the quantum connection forged in that initial fireball remained, a permanent, invisible thread tying them together across the expanding void. Their shared history is written into their very spin and their stellar heartbeat. Another, more profound idea suggests that what we call empty space is not empty at all. The vacuum may be a vibrant quantum field, and these galaxies are like knots in that field, their immense mass and energy creating localized excitations that remain perpetually linked through the underlying fabric. They are not communicating faster than light. They are simply different parts of the same underlying entity, their separation an illusion of our limited perception. This entangled cluster is the ultimate challenge to our lonely view of the cosmos. It suggests that separation itself may be a fragile concept, and that on the grandest scales, the universe is fundamentally, inseparably one. What does it mean for our own place in the cosmos? To think that our Milky Way might be quantum handcuffed to a distant island of stars we have never even seen. This silent wound in the cosmos, where physics unravels, finds its ultimate expression in a region where time itself bleeds backwards. Astronomers call it the anti-temporal field, a pocket of space where the fundamental arrow of time has been reversed. The evidence is as baffling as it is direct. Within this field, radioactive isotopes do not decay into stable elements, they regenerate. A lump of uranium-238, which should be slowly turning into lead, is instead gaining mass, its atomic nuclei reassembling themselves as if a cosmic film were being played in reverse. Even the light behaves unnervingly. Stars positioned behind this field appear to be emitting light that travels backwards, with the absorption lines in their spectra inverted, a telltale sign that the light is arriving before the event that supposedly caused it. It is a place where effects precede their causes, where the universe's most ingrained narrative has been flipped on its head. How can a region of space simply decide to run in reverse? The theoretical underpinnings point to conditions of almost impossible exoticism. One possibility is the existence of a stable region of negative energy density. We are used to energy being a positive quantity, but certain quantum field configurations can, in theory, create areas where the energy density drops below zero, effectively creating a kind of anti-gravity. This repulsive force could be so extreme that it warps spacetime into a configuration known as a closed time-like curve. In such a curve, the path an object takes through spacetime loops back on itself, allowing travel into its own past. Within the anti-temporal field, this isn't a path for a spaceship, but the default state for every particle and photon. The entire region is caught in a perpetual, self-contained time loop. This leads to the profound and unsettling question of origin. Is this a natural anomaly, a rare and unstable knot in the fabric of the cosmos that formed spontaneously? Or are we looking at something that was made? The precision and stability of the field are what fuel the more extraordinary interpretation. Could this be the result of an experiment conducted by a civilization that mastered the laws of quantum gravity? A culture capable of such a feat would not be merely exploring space, but editing time itself. Perhaps this field is a laboratory, a controlled environment where they study the origins of the universe by running physics in reverse. Or maybe it is a refuge, a place where they can isolate themselves from the forward march of entropy, creating a sanctuary where nothing ever ages or decays. The most chilling possibility is that it was an accident, a cataclysmic malfunction of a time manipulation technology that locked a vast volume of space into this paradoxical state forever. The anti-temporal field hangs in the void, a silent challenge to our linear experience of reality. It forces us to ask if the flow of time is a fundamental law, or merely a local custom, one that can be suspended by forces, whether natural or artificial, that we are only beginning to perceive. This silent, sentient cloud of gas glows with a soft internal light, its tendrils shifting and reforming like the branches of a vast, sleeping brain. When astronomers bathe it in a specific frequency of radio energy, the entire nebula flinches. It contracts, pulling its luminous arms inward as if recoiling from a touch, then slowly, deliberately, unfurls into a new, more complex shape. This is not the chaotic churn of stellar winds or the simple push of radiation pressure. It is a pattern, a sequence of actions that looks unmistakably like a response. The debate this living nebula ignites cuts to the very core of what we define as life. Could this be a form of intelligence born not in water or on rock, but in the ionized soup of a star nursery? We know plasma, this fourth state of matter, can exhibit self-organizing behavior. In laboratories, we see simple plasma structures form helices and filaments that maintain their shape. But this nebula operates on an entirely different scale, its behaviors imitating the basal instincts of biology. It seeks out regions rich in certain gases, its tendrils stretching toward them. It shies away from the harsh radiation of nearby stellar flares, a primitive form of avoidance. Is it merely a hyper-complex chemical system, a cosmic slime mold operating on automatic, physical impulses? Or are we witnessing something far more profound, a consciousness woven from lightning and gas, a mind that thinks in epochs and feels in stellar winds? The implications are staggering. If this is life, then the cosmos may be teeming with beings we never thought to look for, entities that live between the stars, their thoughts as vast and slow as the orbits of planets. They would not build cities or radio transmitters. Their entire existence and expression would be the beautiful, terrifying dance of their own luminous bodies. This nebula forces us to expand our imagination, to consider that the spark of awareness might be a universal potential, waiting only for the right conditions to flicker into being, whether in a cell of water or a cloud of fire. There is a rhythm to the darkness between the stars. Our 40-second mystery uncovers a cosmic hum so profound, it seems to be conducting the very architecture of NGC 262. Astronomers mapping the galaxy have found a bizarre correlation, a pattern that should not exist. The distribution of its galaxies, the way they cluster and gather, aligns with the mathematical peaks and troughs of a specific resonant frequency. This rhythm is not tied to any visible force, but to the value of one of the universe's most fundamental numbers, the fine structure constant. This constant governs the strength of the electromagnetic force, dictating how atoms hold together and how light interacts with matter. It is supposed to be a fixed, unchanging number throughout the cosmos. Yet here, its value appears to subtly shift in a wave-like pattern that perfectly matches the large-scale structure of the galaxy. It is as if the invisible scaffolding of the cosmos is vibrating in tune with the force that binds atoms. The only entity vast and mysterious enough to be conducting this symphony is dark energy, the repulsive force accelerating the universe's expansion. We have always thought of dark energy as a smooth, uniform pressure, a kind of anti-gravity infused into empty space. But this harmonic resonance suggests it might be dynamic, pulsing with a specific frequency that gently guides where matter condenses and galaxies are born. Think of a singer shattering a wine glass with a single pure note. Now imagine that note is being sung by dark energy itself, and the wine glass is the void, crystallizing into galaxies at the points of maximum resonance. This discovery could be the master key to a unified theory of physics. For decades, scientists have struggled to unite gravity, which shapes the cosmos, with the other three fundamental forces, which govern the atomic world. They operate under completely different rules, and no single theory can describe them all. But if dark energy, which is fundamentally linked to gravity and the expansion of space, is resonating with a constant from the quantum world, it means there is a bridge. The immense and the infinitesimal are not separate kingdoms. They are speaking to each other through this universal vibration. The harmonic resonance in NGC 262 is a whisper of that conversation, a hint that the force pushing the galaxies apart and the force holding your atoms together are two verses of the same cosmic song. What other secrets might we unlock if we learn to listen to the music of the void? Even the most turbulent storms of gas find an impossible stillness here. Our 43rd mystery lies within the crushing atmosphere of a gas giant, a world where the very air has solidified into a global ocean of liquid metal. This is the metallic hydrogen ocean. Under pressures 1,000,000 times greater than Earth's sea level, hydrogen, the lightest and simplest element, is transformed. Its atoms are squeezed so tightly that their electrons break free, creating a shimmering, electrically conductive fluid that flows in vast, silent currents. But this ocean does not move like any sea we know. Its waves do not crash in chaotic foam. Instead, they rise and fall in perfect geometric rhythms, tracing hexagons, pentagons, and intricate tessellating patterns across a planetary scale. The surface resembles a vast, shimmering circuit board, etched by a cosmic engineer. What force could choreograph a global ocean into a perfect, silent dance? The immense magnetic field of the gas giant is the most likely conductor. Generated by the churning metallic hydrogen deep in its interior, this field could be so powerful and complex that it literally grips the ocean's surface. The moving charged particles within the liquid metal would be slave to these invisible lines of force, organizing their flow into the stable, repeating patterns we observe. It would be like scattering iron filings on a sheet of paper above a magnet. The filings instantly snap into the magnetic field's lines. Here, the entire ocean is the iron filing, and the planet's own heart provides the magnet. Yet, the precision is baffling. Natural magnetic fields tend to be messy, prone to fluctuations and shifts. The stability of these perfect shapes over millennia suggests a system in perfect equilibrium, a balance so delicate it seems almost designed. This leads to the more unsettling possibility. Could these patterns be a form of computation? A civilization that could survive such extreme pressures might use the planet itself as a colossal processing engine. The flowing metallic hydrogen, guided by magnetic fields, could be solving problems or running simulations on a scale we cannot fathom. The ocean would not be a natural wonder, but the core processing unit of a planetary-scale computer, its shifting geometric waves representing the flow of information itself. Is this a world, or is it a machine? The metallic ocean holds its gleaming, silent patterns, a testament to the fine line between a universe of magnificent physics and one that might have been intentionally engineered. The silent, geometric patterns of that metallic ocean find a strange and violent echo in the depths of space. We now encounter a form of life so alien that we have been staring right through it for decades. The 44th mystery is the cosmic ray organism, a hypothesis that certain patterns of ultra-high-energy cosmic rays from NGC 262 are not random stellar shrapnel, but the genetic code of a cosmic-scale entity. These are not just high-energy particles. They are the very language and substance of a being that lives in the spaces between stars, using radiation as its medium of existence and communication. We have been trying to listen for radio signals, but what if the message is being shouted at us in the universe's most powerful voice? When astrophysicists analyze the arrival times, energies, and directions of these cosmic rays, they find a structure that defies probability. The particles arrive in clusters that form intricate, nested patterns, similar to the way base pairs form the rungs of a DNA ladder. The sequences are not random noise. They exhibit a mathematical complexity and redundancy that is the universal hallmark of an information-rich code. It is the difference between the sound of rain on a roof and the sound of a spoken sentence. One is a natural process. The other is packed with structured meaning. So what would a cosmic ray organism look like? Imagine a vast, diffuse intelligence whose body is not made of cells, but of entangled quantum fields and high-energy particle streams. Its thoughts would be the intricate, orchestrated collisions of cosmic rays, and its memories would be stored in the quantum spin of photons traveling for millions of years. This entity would not have a single, localized brain. Its consciousness would be distributed across light years, a shimmering network of energy and information woven through the galactic void. Its life cycle would be as strange as its form. It might feed on the turbulent magnetic fields of nebulae, or reproduce by seeding its complex code into the stellar nurseries of new galaxies, ensuring its pattern is reborn with the next generation of stars. Communication for such a being would be instantaneous across its own vast network, as the entangled particles that make up its mind are already connected, ignoring the speed of light. When it wants to speak to another of its kind, it might not send a signal, but simply alter the fundamental resonance of its local spacetime, a vibration felt across the cosmos. This leads to the most profound and unsettling question. Could our own universe be alive in a way we have never comprehended? The cosmic web of dark matter and dark energy, the large-scale structure of everything, might not be a static backdrop. It could be the circulatory system or the neural network of a single, galaxy-spanning organism. And these patterned cosmic rays are simply the biochemical signals we have just learned to detect. We are not just living in the universe. We may be living inside a being whose thoughts are the laws of physics themselves, and we are only now beginning to hear its whisper. A silent seamstress works in the depths of the galaxy, weaving a thread of pure geometry. This is the space-time fabric weaver, a linear anomaly that appears to be darning the very cosmos back together. It is a perfectly straight, impossibly long filament of energy, and wherever it passes, the chaotic wrinkles in space-time are gently smoothed flat. We see its work in regions where the gravity of dense star clusters should be tearing at the fabric of reality, creating microscopic black holes or gravitational turbulence. Yet in its wake, space is calm, stable, and paradoxically serene. It is as if a cosmic tailor is constantly running a stitch along the fraying edges of the universe, reinforcing the seams to prevent a catastrophic unraveling. So what force could possibly mend the fabric of reality itself? One profound possibility is that we are witnessing the work of a cosmic string in its most benevolent form. These theoretical relics from the Big Bang are often portrayed as destructive, but perhaps their immense mass and unique gravitational fields have a stabilizing effect. As this cosmic string moves through the galaxy, its incredible gravity might not just bend space, but iron it out, canceling out smaller gravitational ripples and preventing any single knot of energy from becoming tight enough to collapse into a singularity. It would be a natural, if incredibly rare, regulator, a built-in safety feature for the cosmos that ensures gravity never gets too rowdy in one neighborhood. But the precision of this effect is what fuels a far more staggering idea. Could this be the work of a technology, a civilization that perceived the inherent instability of the universe, the tendency for matter to eventually collapse into dark pits, might have decided to intervene? They could have engineered this structure as a form of cosmic maintenance, a permanent repair mechanism to prevent the formation of natural singularities and preserve the galaxy as a stable habitat for life. The energy required would be godlike, but the intention is hauntingly familiar, the desire to fix a leaky roof before the whole house floods. This weaver does not create or destroy, it simply preserves. It poses a silent question about the nature of the universe itself. Is reality a wild, untamed wilderness, prone to its own violent collapses? Or is it a garden, one that requires the careful, unseen attention of a gardener to keep it from consuming itself? This single thread, stitching the void back together, suggests that the greatest forces in the cosmos may not be those of creation or destruction, but of silent, endless repair. This faint microwave whisper is the cosmic fossil of a reality that came before our own. Permeating every corner of NGC 262 is a ghostly signal, a thermal echo that is almost, but not quite, the cosmic microwave background. That background is the remnant heat from the Big Bang, the afterglow of creation that fills our entire universe with a nearly uniform coldness. The echo in this galaxy is different. It is a subtle patch of slightly warmer microwaves, a gentle thermal hill in the cosmic landscape, and it carries a unique polarization, a twist in its light that the standard background does not possess. It is as if we are hearing two distinct choirs singing the same hymn, but one is singing in a slightly higher key and facing a different direction. This is not simply a local anomaly. It is a fundamental clue, a scar on the face of our cosmos that points to a staggering origin. The leading theory is that we are detecting the literal imprint of a collision with another universe. In the framework of eternal inflation, our universe is just one bubble in a vast, frothing multiverse. These cosmic bubbles can sometimes drift close together and gently bump. The energy released in that collision would leave a permanent mark on the sky of both universes, a circular bruise of altered temperature and polarization, exactly like the one we see imprinted across NGC 262. This means the galaxy is not just looking out into our universe. It is looking through a window at the wall of a neighboring reality. Another profound possibility is that this is the echo of a previous cosmic cycle. Some models of cyclic cosmology propose that the universe undergoes endless cycles of expansion, collapse, and rebirth in a big bounce. Each time, nearly all information from the previous cycle is wiped clean, but not all. A faint thermal signature, a memory of the old universe's final state, could be imprinted onto the new one, like a watermark on a freshly made sheet of paper. The signal in NGC 262 would then be the dying breath of a cosmos that existed trillions of years before our own. Its final sigh forever frozen into the foundation of our own reality. This single, faint signal forces us to confront the grandest questions of all. Was there a before our Big Bang? Are we alone in existence? Or is our universe just one room in an infinite cosmic hotel? This microwave echo is our first tangible piece of evidence that our creation may not have been a singular, isolated event, but part of an endless, majestic tapestry of realities, each with its own laws, its own stars, and its own ghosts. A star and its world are locked in a fatal chemical embrace. This is no serene orbital dance, but a cosmic merger in progress, a system where a planet orbits so close to its sun that their atmospheres have become one. The planet, a gas giant, skims the star's fiery corona, its outer layers being violently stripped away by the stellar wind, while simultaneously injecting its own unique chemistry into the star's plasma. They are no longer two separate objects, but a single, churning hybrid, a star-planet entity with a shared and turbulent gaseous body. The conditions are beyond hellish, with temperatures soaring to thousands of degrees and magnetic fields whipping the mingled atmospheres into a frenzied soup. Yet within this stellar crucible, something astonishing is happening. The complex chemical exchange between the planet's hydrogen-rich, carbon-laced atmosphere and the star's seething brew of helium and heavier elements is creating molecules that should not survive here. Spectrographs have detected the fleeting signatures of complex carbon chains and even simple amino acids, the fundamental building blocks of life, swirling in the interface between star and planet. It is as if a chemistry set the size of a solar system is running a continuous, violent experiment. How can such delicate structures form in a stellar forge? The planet's atmosphere may act as a temporary shield, a protective pocket where these molecules can rapidly assemble in the brief moments before they are torn apart by the star's immense energy. This is not a gentle, planetary-scale laboratory. It is a frantic, ongoing explosion where creation and destruction happen in the same instant. Could this chaotic, high-energy environment be a cradle for a form of life we cannot even conceive? We imagine life needing a rocky world and liquid water. But what if life could emerge in a cloud of charged plasma, thinking thoughts of lightning and nuclear fire? The symbiotic system offers no answers, only a profound and unsettling possibility that the universe might be able to spark awareness in the most violent and impossible of places. This steady rhythm finds its purest form in a beacon that does not shine. Deep within the galactic halo, a source emits a continuous, low-frequency hum, a pulsating signal written not in light, but in the stretching and squeezing of spacetime itself. This is the gravity wave lighthouse, and its song is one of immense, controlled power. Unlike the brief, rising chirp of two black holes colliding, a catastrophic event that ends in silence, this signal is a metronome. It pulses with a perfect, unvarying rhythm, a deep bass note that has been playing for eons, untouched by the chaotic dance of stars around it. So what cosmic instrument could possibly play such a stable, resonant note across the fabric of reality? One of the most likely natural explanations is a spinning neutron star with a profound deformity. Imagine a pulsar that is not a perfect sphere, but has a permanent mountain range on its surface, a bump just a few inches high. As this ultra-dense object spins hundreds of times per second, that tiny imperfection would whip through spacetime, rhythmically disturbing it and generating a continuous stream of gravitational waves. The incredible stability of the spin would create the steady pulse we detect, a testament to the rigid perfection of a dead star's corpse. Yet, the sheer power of the signal pushes this idea to its limits, requiring a stellar object of almost impossible density and spin. A more exotic possibility is that we are detecting the throat of a stable wormhole. A traversable wormhole would need some form of exotic matter to keep its passage open, and the oscillations of this matter, or the very rotation of the wormhole's entrance itself, could theoretically produce a steady, rhythmic emission of gravitational waves. In this view, the gravity wave lighthouse is not a star at all, but a gateway, a tunnel through spacetime whose mere existence causes it to ring like a bell with a specific, fundamental frequency. Then there is the most staggering explanation of all, that this is not a natural object, but a machine. A civilization that had mastered gravity might use such a beacon for navigation across the vast, empty gulfs between galaxies. Light can be dimmed by dust and gas, but gravitational waves pass through nearly everything unimpeded. A steady, powerful pulse like this would be the perfect cosmic lighthouse, a fixed point in the swirling dark that any ship with the right technology could use to chart its course. Or perhaps the signal is not a beacon, but a byproduct. This could be the exhaust plume of a gravity drive on an unimaginable scale, a propulsion system that works by rhythmically warping spacetime to push a vessel forward. The continuous pulse we detect would be the wake of this engine, the regular beat of its footsteps across the cosmos. Is this the hum of a natural stellar heart, the resonant ring of a cosmic tunnel, or the silent, rhythmic thrust of a ship too vast for us to comprehend? The gravity wave lighthouse offers no easy answer, only a deep and persistent rhythm that asks us to listen more closely to the silent music of the universe. This silent gravity wave hums across a galaxy that is quietly tearing itself apart. The 49th mystery is the phantom energy reservoir, a void within a void that is actively pushing the cosmos toward its end. In a remote part of NGC 262, a spherical region of seemingly empty space is not just expanding with the universe, it is accelerating that expansion at an alarming rate. This is not the gentle, uniform push of dark energy we observe everywhere else. This is a localized fountain of phantom energy, a hypothetical and terrifying form of dark energy where the pressure is so negative. It actually causes the expansion to speed up over time, growing stronger as space stretches. Imagine a car rolling down a hill, but instead of friction slowing it, the hill itself gets steeper and steeper the further the car travels, until the slope becomes a vertical cliff. That is the relentless, self-amplifying nature of phantom energy. The reservoir itself is a perfect enigma. Our telescopes see nothing there, no stars, no dust, not even the faint whisper of the cosmic microwave background. It is a hole in the cosmic map, but its gravitational footprint is immense. It is not pulling things in, it is actively pushing everything away, creating a growing bubble of nothingness that is forcing the surrounding galactic structure to stretch and strain. If this local phenomenon is a preview of a universal future, the implications are catastrophic. This is not merely a distant curiosity, it is a countdown clock for the entire cosmos. If phantom energy were to become the dominant force everywhere, it would lead to a fate known as the Big Rip. First, the phantom energy reservoir would grow, severing the gravitational bonds of the galaxy cluster. Then, individual galaxies would be torn apart, stars ripped from their orbits. As the acceleration becomes infinite, solar systems would be shredded. Planets would be pulled away from their suns. Finally, in the last terrifying moments, atoms themselves would be torn asunder, with even atomic nuclei unable to withstand the violent, repulsive force. Every structure, every piece of matter, would be violently dissolved into a thin, expanding mist of fundamental particles, forever isolated in an ever-cooling, utterly empty void. The existence of this reservoir forces a profound and unsettling question. Is this a natural, if rare, cancer in the fabric of spacetime, a random flaw that has formed in this one galaxy? Or is it something far more deliberate? Could this be the footprint of a technology, a weapon of ultimate destruction tested in a remote corner of the cosmos, or a failed experiment in manipulating the vacuum of space that unleashed a force its creators could not control? This silent, expanding sphere of nothingness is more than a scientific puzzle. It is a warning, a glimpse of a possible future where the universe itself turns against the very structures it spent billions of years to build. This final mystery unravels the very foundation of reality itself. Across the vast expanse of NGC 262, the fundamental rules of the cosmos are not fixed. They are changing. The speed of light in a vacuum, the strength of gravity, the fine structure constant that dictates how atoms hold together. These are not the universal pillars we have always believed them to be. Instead, they shift, creating a subtle but measurable gradient from one side of the galaxy to the other. Imagine if the rules of chess changed slowly but surely as you walked across a giant game board. A pawn might suddenly be able to move 3 spaces, or a knight's L-shaped jump could become a straight line. The entire logic of the game would break down. This is the scale of the discovery within NGC 262. The constants of nature are not constant at all. They are local customs, written by the environment of the space they occupy. How do we even measure such an impossible thing? The evidence comes from the light of distant quasars, the brilliant hearts of ancient galaxies. As this light travels for billions of years through different parts of NGC 262 on its way to us, it passes through clouds of interstellar gas. These clouds absorb specific wavelengths of light, creating a unique barcode in the spectrum, a fingerprint that depends critically on the value of the fine structure constant. When astronomers compare these fingerprints from light that has traversed different galactic paths, the barcodes do not match perfectly. The lines are shifted, indicating that the constant which governs the strength of electromagnetic interactions was slightly different in one part of the galaxy compared to another when the light passed through. It is a tiny variation, but its implications are cosmic. One profound explanation is that these constants are tied to the density of dark energy. If dark energy is not perfectly smooth, but has hills and valleys of varying intensity, then the vacuum of space itself would have different properties in different locations. In a region of higher dark energy density, the vacuum could be stiffer, subtly altering the way light propagates and forces interact, effectively changing the local speed limit for light and the pull of gravity. Another, even more mind-bending possibility is that our universe is merely one bubble in a vast multiverse. In this endless froth of realities, each bubble has its own unique set of physical laws and constants. Most are sterile, incapable of forming atoms or stars. A rare few, like ours, are just right for life. The gradient in NGC 262 could be a place where our bubble is pressing against another, a neighboring universe with slightly different rules. At the boundary, the constants are bleeding into one another, creating a slow cosmic transition zone where the laws of physics themselves are in flux. This single galaxy forces a humbling realization. The elegant, unchanging laws we have used to define reality are not the final word. They are a regional dialect, a set of rules that work in our local cosmic neighborhood, but may be utterly different elsewhere. The universe is not just stranger than we imagine. It may be stranger than we can imagine. A patchwork of different physics where the only true universal law is variation itself. 50 strange phenomena, one single galaxy, and a universe of questions left wide open. From the phantom pulsar that vanishes on a whim to the cosmic laws that shift like sand, our journey through NGC 262 has revealed a cosmos that thrives on the impossible. Each of these 50 enigmas is more than a scientific curiosity. It is a direct challenge to the limits of our understanding, a crack in the foundation of what we thought we knew. These are not mere puzzles to be solved, but profound reminders that reality is far stranger, far more complex, and infinitely more wonderful than our finest theories can currently describe. They humble us, forcing a recognition that we are only just beginning to learn the language of the universe. So we turn the question to you. Out of all these wonders, which one captured your imagination the most? Was it the silent construction of a Dyson swarm, the ghostly touch of shadow matter, or the living nebula that seems to think? Share your thoughts in the comments below, because the conversation about our cosmos is just getting started. Keep looking up, stay curious, and remember, the next great discovery, the next reality-shattering mystery, is always waiting just around the next